Excellent. Good morning. Very happy to see all of you here. My name is Oleg Šelajev, and I come from Estonia, and I work as a developer advocate on the GraalVM team at Oracle Labs at Oracle. And if you have any questions that you will not get the chance to ask me here, I encourage you to find me on the internets and almost universally go by @Šelajev, so you can tweet at me or GitHub issues me or I don't know, find me on LinkedIn and ask all your uncomfortable questions about GraalVM and JVM languages and life in general and well, like everything. Oracle Labs is a research and development institution within Oracle, so its goal is to actually do science, right? To push the boundaries of what we know about the computer science and how to write virtual machines and how to write programming languages and whatnot, and then eventually to convert that accumulated knowledge into the products for the industry, so we as an ecosystem could benefit from them. So GraalVM is one project that is coming from Oracle Labs, and today we're going to talk about this and how it can help Kotlin developers and in which scenarios you would like to use GraalVM as a runtime and what it can do. This is a technical presentation, so please do not make any forward-going business decisions based on contents of this. This is very important. And with that legality out of the way, let's talk about GraalVM. How many of you have heard of GraalVM? Excellent, very good, very good. As a developer advocate for the project, it makes my heart very warm and fuzzy that all of you kind of heard of GraalVM. How many of you think you can explain what GraalVM is? Right, actually more people than usual. Very good, very good. But for the rest of you, you are in the right place, right? Hopefully after this short session, we will learn something and you are more comfortable explaining to other people and understanding what GraalVM is. In one sentence, it's a high-performance polyglot embeddable virtual machine for running programs in different languages. So it's a little bit a complex sentence, right? There are a lot of unpack, but it's high-performance polyglot virtual machine. So GraalVM would like to offer you the following things. The vision for GraalVM is to run programs in all kinds of languages, Kotlin, Java, JavaScript, if you will, Ruby, Python, to run them efficiently, to run them faster than the alternatives could do, and also to make developers more productive by providing this unified runtime environment for all the languages, right? So it's a common platform, and we would like it to become an ecosystem. So all the languages and all the communities writing software in different languages could kind of work together rather than point fingers at each other and laugh about how one part has null pointer exceptions and the other has undefined is not a function or similar problems. So let's all be friendly. GraalVM project goals and the value that you can get from using GraalVM today is that we run languages that we support quite fast, and you can get specifically for the JVM languages and specifically for you for running, say, Kotlin on the JVM, you can get higher performance than otherwise. There is a ahead-of-time compilation mode for JVM-based languages where you can get your application to the native binary, not unlike Kotlin native, but for like the JVM-based languages, including the Java platform. And that could be used in cloud environments where you need faster startup and lower memory overhead. You get the interoperability between languages, which means that you can write your systems in different components in the system in different languages, right? So you can have your Kotlin application, and then you can spice it up with some machine learning in Python. And you don't have to like erect a boundary between those two languages, right? You can use them in the same process, and you can use them efficiently. So there is no memory copying or object copying between those. You just use your Python script that your data scientist has wrote for you as it would be like a part of your normal library. And the tooling that works for languages. And also the embeddability in native and JVM applications. So if you have a platform, like a large platform that does a lot of things, and besides, you would like to extend its capabilities with small programs in other languages. For example, you have something like some sort of space, right? And then you would like to extend that with plugins written in, not just in Kotlin, but potentially JavaScript. Because there are like almost anything you would wish to ever write has been written in JavaScript. So maybe you can just reuse that code. So GraalVM could offer you a runtime where you'll be able to customize your large application with this particular ability to run, say, JavaScript or Python efficiently. So if you have large platforms, if you have large applications that could become polyglot, then you should look at GraalVM. But mostly, and the most well fleshed out stories currently for GraalVM is the higher performance and the low footprint mode for applications. And of course, that means that we are concentrating on the server side of things, right? So GraalVM is a runtime, not unlike a JVM, and it includes a JVM, but we are gonna target server side. Initially, when I was preparing to come here, I thought that is a big story in the Kotlin ecosystem. And well, yesterday, Andrea at Keynote explained to me that Kotlin ecosystem was much larger. So I feel like this is very important to concentrate. Currently, there is very little that GraalVM can offer for you for, say, mobile development. There are some experiments, but we're gonna touch on that. So we're gonna concentrate on server side. What GraalVM is, it's a polyglot runtime, and we have a number of languages that we support, right? So JVM languages, including Kotlin. We have Ruby, Python, JavaScript, R. We have native languages that go through the LVM toolchain. We also have an experimental support for WebAssembly. So if you would like to execute some WebAssembly, you can run it on GraalVM as well. And as I said, you can run it in different environments, in different modes. You can run it inside your JVM. You can run it inside a proper node instance, and you would have your node event loop and whatever. So if you have colleagues who write node applications and you would like to share the joy of using a Kotlin library with them, you can use the runtime that can execute both. There is a standalone mode for this AOT compilation, and you can embed it in large applications. And there are some experimental builds of the Oracle database where GraalVM can be used for running stored procedures as JavaScript, which is quite interesting. Right, so GraalVM is a large project. It's an open source project. And it consists of several very important parts. There is a core of, altogether it's a little bit more than 3.5 million. And this is a rough estimate, right? We didn't actually count lines of code and verify that this is a useful line of code versus like a curly brace or something. So it's an estimate, but there are a large chunk, which is the compiler, which is at the heart of the GraalVM project. This is a just-in-time compiler for JVM bytecode. Can be used as a ahead-of-time compiler as well. There is a framework for implementing managed languages called Truffle. There is a runtime bits, like garbage collection, that will go into the platform binary when you compile ahead of time. And there is, of course, support for the existing languages. And as you can see, there is no WebAssembly even yet, because we added that just recently. And also some tooling. So for the polyglot story, it's very important that you do not get into mess that you cannot debug or you cannot profile your application written in different languages, right? That would be kind of unfortunate. So GraalVM provides tooling for that as well. But for JVM languages, and I'm gonna boldly assume currently that Kotlin is a JVM language, despite other platforms for Kotlin as well. GraalVM offers two main advantages, right? It can run as a Java, and it can run as the platform binary. And both of them offer you different performance impact, and you would be interested in using them in different contexts. So we're going to talk about the running as a normal Java process in the JIT mode, using just the normal Java hotspot VM, where GraalVM replaces the C2 compiler, the top-tier optimizing JIT compiler. It replaces with the GraalVM compiler. Right? So it's a normal, when you run Java from GraalVM, you download GraalVM, you unpack it, you type GraalVM/home contents bin Java, right? It starts normal Java hotspot virtual machine. that comes from the OpenJDK project. And then you can run, and you can, the benefit of using GraalVM is that the compiler has very good high-level optimizations, right? It might not have the best low-level registry allocation yet. We will get there eventually, or like the bit fiddling techniques. But what it shines at is at high-level optimizations, which allow you to write highly abstracted code that you don't have to suffer from performance impact, right? So if you would use something in Java, right, or I'm not sure actually how to translate this idiom into Kotlin. Unfortunately, I don't have enough Kotlin experience. But the idea is that very often we try to structure a code in a defensive manner, or restructure a code to be more performance aware, right? So for example, if we know that some logging is disabled, then before calling the log function and passing the parameters and making it evaluate everything, and then do nothing because the logging is not enabled, we actually wrap it up in another if block. And this is a very common idiom. Or there is another stuff where we know that we would like to use high-level abstraction utility functions, right? But we know that the performance-sensitive code is something, and we would rewrite it to actually kind of like manually inline the contents of the utility that we would like, right? And I hope you recognize, at least not even if those particular examples, but the idea that sometimes as developers, we think that, oh, our runtime will not be smart enough to offer the best performance. So we need to help it with doing kind of like ridiculous tricks, right? This is something that the runtime should do for you. So Chris Nealand, who is a performance expert and wrote a couple of books on performance, says that for his team, he says that please do not use any high-level abstractions. No functional programming, no advanced object orientation. So does that mean that you should not use like higher abstract languages as well, right? You should not use Scala or Clojure or Kotlin because you will get performance impact. So as the runtime developers, for us, this is kind of unfortunate. So the GraalVM vision is that the runtime should be smart enough to allow you to write code in the way that you want. If you want factories, you should have factories in your code. If you want stream API processing, and if you want reactive streams, you should write your code using reactive streams. You should not think about whether a for loop or a stream-based approach is faster, right? Because that is a job for the compiler to figure it out. So, and GraalVM makes steps to achieve that vision, right? So obviously, no one is perfect, and you can always have a limit somewhere for the abstractions, but we are making steps for that. How you can do that? You can download GraalVM. It comes as a JDK distribution. You can open that, add it to the path, and run your Java applications normally, and your Kotlin applications normally, and hopefully it will be faster. And I'm going to run one benchmark here just for you. And it's not a scientific benchmark, but I just want to show you some results because I hope it's kind of like very interesting. It's kind of very interesting. Let me remove this. So it's a very simple benchmark. So we just have a bunch of integers, and we just would like to convert them to a sequence and to map a couple of functions over that and just reduce that. It's a very simplistic kind of synthetic code, right? But I just want to give you a short example because I can run it in front of your eyes, and you will see that there is no trickery involved, hopefully. Right? So it's a JMH benchmark, and originally I wanted to show you the benchmarks that Roman is showing in the main hole, where he compares Kotlin Flow to other implementations of the reactive streams to show that Flow is better. And he has benchmarks to kind of prove that. And I wanted to run those benchmarks and show you the difference that the GraalVM runtime makes on those. But there is one issue with the loops inside Kotlin coroutines, which is currently outstanding, and I'm gonna touch on that a little bit later. So unfortunately, I couldn't. So we're gonna run this synthetic benchmark, and I'm gonna run this normally, and I'm gonna run this using my Java command. So for the tricks, I will do which Java, right? And this is my Java, and this is Java 8-based distribution of GraalVM EE. So I'm gonna run my benchmark here with C2, right? To do so, I will disable. I will still run the. I will still run view presentation mode. Wait. Sorry. Where's my terminal? Okay, exit presentation mode. Sorry about this. We're not gonna bother with this anymore. Where's my terminal? Exit presentation mode. Terminal. Doesn't matter. I'm gonna run this benchmark, and I'm gonna not touch my computer for 40 seconds or for 2 minutes for some time, just to show you the results. And I'm gonna talk about what happens behind the scenes. So I'm using the hotspot as it is, but I'm using it from the GraalVM distribution. But I'm also disabling the GraalVM compiler. So currently, this is the setup as you would get when you would run with the JDK, normal open JDK, with C2 as the top-tier optimizing compiler, right? We're gonna wait like a little bit more, but you can see that the results are stabilizing to a certain extent. So don't trust this benchmark, right? First of all, because this is a benchmark that I'm showing you from stage, so you know that there is some marketing component involved, absolutely, and it's not just because of me, because I'm like sneaky Oleg for you here. It's anyone. When anyone shows you benchmarks from stage, take them with a grain of salt, right? You always have to interpret the benchmarks and understand what's happening there. And this is not a rigorous benchmarking environment. This is my MacBook from several years ago. It runs Docker. It runs with additional screen. There is turbo boost and whatnot. So you know that these results are not very scientific. But also these results that I'm going to show you are a little bit understandable, that you can extrapolate. Hopefully you will see the difference and you will be like, this is interesting. Maybe I should look into trying GraalVM. So I'm going to stop it. You can see that the numbers kind of stabilized approximately near the 1,500 operations per millisecond. So what we do? Where's my? No, wait. Simple benchmark here. So we run this benchmark 1,500 times a millisecond, right? And you can see when I start moving my mouse, the performance drops. But this doesn't matter. So now I'm going to run the same benchmark, but I will not disable the GraalVM compiler. And my Java from my GraalVM will use the GraalVM compiler as the top-tier JIT compiler, and I'm going to run, and hopefully it's going to show us a little bit better numbers. So we had 1,500 operations per millisecond, and now in 10 seconds, hopefully we'll see a number which is what? Which is a little bit higher than 1,500 operations per millisecond. And so it will also stabilize somewhere in the 18,000 operations per millisecond, and this is a very surprising result, because JVM as it is, the normal JVM, like hotspot, is a state-of-the-art virtual machine, right? We use it and we know that it runs and it makes code really efficient. But the difference that the GraalVM compiler can make is very significant, especially when you run code that is more abstracted than a single loop that runs over the array of primitive doubles or something. So here in this example, we create a sequence, we lazily map functions over it, so the data has to flow. There are intermediate objects which are created, and it's a complex bit of code actually. And you can see that other compilers could struggle with it a little bit. So you will not see this type of performance boost when you run your actual application, right? So it's a little bit ridiculous to assume that you can run it 700 times faster or something. But you will see a difference, specifically if you write in different languages than Java, right? So because the bytecode patterns that Kotlin produces, or that, for example, Scala produces, or that Clojure produces. They're a little bit different from the bytecode patterns that the normal Java programs produce, right? So Java programs and C2 compiler kind of grew together, and they made sure that they are kind of optimized for each other, right? So that's why your Java programs could run better on C2, and the performance boost there could be less significant. For Kotlin programs, which are typically like a little bit higher in abstraction usage, you can see better results. And for the other JVM languages, or if you just use abstract concepts. So GraalVM optimizations, the optimizations that GraalVM does here, which allow this, is we have really, really strong inlining. So that means that we can actually see through all of this and kind of inline that into doing nothing, right? So it doesn't actually lazily have to create and evaluate the map functions all the time. And escape analysis. So we don't have to create objects all the time, because GraalVM can figure out that when the objects are not used, and it uses a much more pragmatic policy for that than C2. So C2, for example, has to make sure that the object doesn't escape the current local memory, and no one else can see it on the meta level, right? And the GraalVM can do that in a conditional. So if an object escapes on one branch of a conditional, but doesn't escape on the other, so we can avoid allocating this object until it actually has to be allocated, right? So this allows us to remove the garbage collections, remove the object allocation pressure, because we don't have to create objects. Sometimes we can more operate on the primitives rather than boxed integers and numbers. So all in all, escape analysis and better inlining give you performance boost here. Obviously, GraalVM compiler implements all other normal optimizations like anyone else, the dead code elimination and the loop optimizations and the deduplication and copying pieces of code to avoid megamorphic calls and whatnot. So it's a state-of-the-art compiler, and you can use it very simply from just by downloading the thing. So there is no reason not to try what I'm trying to say. And of course, we run tons of benchmarks. We run more benchmarks than just simple synthetic test on a poor MacBook on stage. And we also know that the GraalVM compiler offers a very good competitive performance, right? GraalVM can come in two versions. There is an open source project, which it's a fully open source. You can try, build, run it, and it shows good results. And then there's a GraalVM Enterprise, which is a product by Oracle, which shows even better performance because it comes with additional optimizations and enhancement in the compiler. But you can try, obviously, both. So if you look at the benchmarks, and if you want to see more benchmarks than just some sample code, we have this suite of benchmarks called Renaissance, which GraalVM team, some people would know the GraalVM team helped some universities to create. So it was a joint effort. And the goal for that was to run more modern JVM workloads than other benchmark suites do normally, right? So if you look at the benchmarks that we normally run as an industry, they are a little bit older than maybe some projects that we currently are working on, right? So if you look at Spec JVM 2008, it was created around 2008, right? Or Da Capo or something. And then several years ago, we wrote our JVM applications differently. For example, probably you didn't write any JVM applications in 2008 in Kotlin. So we wanted to create a different benchmark suite that kind of exercises maybe other parts of the JVM that other benchmarks do not, right? So to show performance on the more modern workload. And here in the Renaissance, you can see there is some Akka, there is some compilers like Dotty for Scala, there was some Neo4j for data analytics, and some other benchmarks which are maybe less represented in more typical benchmark environments. That said, more benchmarks is always good because running just a few benchmarks means that you will make sure that you run those really, really well, but then you will see the real world code and you will be kind of confused by the results, and your compiler will be confused by the results because it has never seen the code like that, right? Because you overfitted for particular benchmarks. So benchmarks are good we think as the team that more benchmarks are always good, right? That's why we started Renaissance. And also, it's very important, you have to realize that benchmarks are not the substitution for running tests on your code, right? I can give you a number, a single digit, like how much better the GraalVM is than, say, OpenJDK, or how much better GraalVM Enterprise Edition is than the Community Edition, and it will mean nothing to you. It will be the average temperature in the hospital, because there is a number of workloads, they have different performance characteristics, and you just combine that into a single number. So what you should do, you should look at your code, you should look at your applications, you should try it, or maybe try it on the sample applications that represent your workload, and then you extrapolate those results. So while more benchmarks is good, there is no going around that trying it on your code. And one thing that you can do, and one thing that we would encourage you to do, is if you see some results that are maybe less than excellent, and you would like to make something faster, then you do not rewrite your code to use like lower level of abstractions. You don't remove your object hash functions and rewrite them in multiplication of integers, right? But you try to solve this problem in a more general way. And the more general way would be to collect the profile that your runtime has when running this code. For example, the Java flight recorder information, and then just share that information with us, right? We can look at that. We can, if you share the flight recorder information on GraalVM and say on OpenJDK, we can see look at the differences. We can see whether there are potential for the optimizations, and we can make it better for everyone, not just for your particular project, right? So, for example, maybe we can make the Kotlin compiler faster, just because. Probably not. People are not convinced. I think we could by providing a faster runtime for that. Maybe not. But maybe that with the new compiler coming, maybe that will be unnecessary. So what I wanted to say, talk to us. If you want some code that to run faster, we would be happy to look into making it faster, right? On a general basis. So this is it. This is how you use GraalVM in the JIT mode, and you get the peak throughput, and you also get the latency of the normal garbage collections in the JDK. Right? So when we talk about performance, it's very important. There are different people. I have time, right? I have 20 minutes. Very good, very good. The applause there kind of threw me off, because we have the material to cover. We should warm up. We should become more efficient at going through the material. So when we talk about performance, different people mean different things. And we learned about that when we went out to people and say, oh, GraalVM is such a great thing. It offers the better performance. And people are like, I write in Go. It starts up fast. So peak performance is one axis for performance. Startup is another one. The low memory footprint is an aspect for performance, which is the most reasonable in the cloud, because there you actually pay mostly for the memory, and everything else comes from the memory. Latency, some people care about packaging a lot, especially on the front end, right? When you don't want to ship the whole JVM to your browser. But on the server side, that could be like a little bit less exciting performance benefit. So in the JIT mode, you get great peak throughput because JIT has visibility into your system, right? It can optimize it to the best of the ability. You get great latency because it's an inverse of the throughput, typically. But the other numbers are maybe not so great, right? So specifically, the startup and memory consumption are a little bit less than desired because the JIT facilities need to allocate memory. They need to do work, right? So that means at startup, your JIT is doing work rather than your application. Sometimes it's not desirable. So the ahead of time compiled mode offers you different trade-offs for performance, right? The ahead of time compiled code will not need to execute JIT or initializations in the beginning of the work, right? So it will have better startup. In the case of GraalVM native images, you don't depend on the JVM, so it gives you really, really good startup. You don't need to allocate memory for the compilation facilities, right? So you get lower memory footprint, especially pronounced on the small services. if you have your application that runs with like terabytes of heap, it doesn't make sense to try to save like 300 megabytes by not using the jet, right? It's not worth it. But if your application is actually like a small server that takes some HTTP requests, writes something in Kafka, sends something to the database, transfers some data, outputs some log statements, and then returns the JSON to the user, which is a lot of use cases actually. Then maybe your application doesn't need to allocate like 300 megabytes or 500 megabytes for GTIN purposes to serve that one request that comes in. So with an AAT mode, you get a different performance trade-off. But the good thing is the GraalVM project offers you both. Not at the same time currently, but it offers you both. So you can run it in a JIT mode, and you can run it in an AOT mode. What happens, there is a utility we call native image that can look at your application, and it takes into account your application, your libraries, your Kotlin jars, your JDK classes from the JDK, and some classes that form the runtime bits like GC, and then initialize the application and compile it ahead of time and output a native executable. Kind of very similar to Kotlin native. But the main difference from Kotlin native is that it actually can transform the applications and compile them when they use JDK facilities as well. Right, so it can compile Java as well, not just going from the Kotlin source to the binary. And there is quite heavy analysis going on, and this process could take a little bit of time, and then you compile your application, but then the results is really good, right? It gives you great startup, and I'm going to show you, and it gives you the great memory usage. So let me go back to my console here. Right? And I have my application here, and it's not a Kotlin application currently, but it doesn't matter because we can transform any JVM bytecode, including the bytecode that Kotlin produces, modulo loops in the coroutines for the issue, and I can build this binary, and I can have the file that doesn't depend on the JVM, and that is just several megabytes large, and I can put it in an empty or very small Docker container, and I can start it very fast as well. And you can see it starts up in just milliseconds, which is very good results for the JVM-based language application. And if I start that, and you can see, I can show it to you in the browser. It's a small application that shows you quotes from a file. It just doesn't do much, but it is sometimes very representative of a small microservice. And I can show you that. Where's my activity manager? Activity manager. Not idea, of course not idea. What quotes up? And my memory. This application at runtime to serve a few requests takes 14 megabytes of RAM. This is the whole RSS of the process, right? It's not the heap. So I can run this application in very small environments, like in a very small pod in a Kubernetes, right? And it doesn't have to consume resources for that. And because it starts so fast, I don't have to actually have the warmed up instances. How many of you run Kotlin native applications on the backend? 4 people. How many of you would like to run Kotlin native applications on the backend, but like cannot actually because of reasons? Okay, maybe you should look into GraalVM. Maybe some of the reasons are because your applications depend on the Java libraries, and Kotlin native cannot handle that. And maybe GraalVM will be able to handle that. So very good, very good. You can see this is a simple application, and it gives you an example, an idea what you can achieve, right? So some technology behind that. So the native image operates under the closed world assumption. So all the bytecodes need to be seen at the generation time. Right? So there is no dynamic class loading after the compilation has happened, which kind of limits a little bit to which applications currently work well. Also, the dynamic parts of using the JVM require some configuration. So, for example, people always at this point freak out about like how I'm going to use reflection. but the reflection actually works quite well. You just need to configure that. Like it's at the static analysis point when we generate this binary, right? We cannot possibly figure out all the usages of reflection that you can have. Like the reflection being a dynamic feature can always cheat static analysis. It's a fact. So it needs the configuration help from you to say, I'm going to use those classes through reflection. I'm going to take my model and I'm going to serialize that to JSON, and I'm going to use reflection for that. So please, the generator, take that into account. There was no problem with actually using reflection. The problem is was automatically determining which bits to include, which bits you can use for reflective access. So one thing is, I'm very happy that currently it's not only me who has to go to people and say that reflection works great, because there is this misconception that reflection doesn't work. So I'm very happy that other projects from the ecosystem kind of start to take interest in GraalVM. And Sebastien, who will be here during the next time slot, talking about Spring applications in Kotlin. He also experimented with Spring applications and GraalVM native images. And he publicly says that the native image has great support for reflection. So have no fear, reflection is supported. You just need to configure that. The best thing is you can embed that configuration in your libraries, in your jar files. I'm not sure if you can embed them in the clip files, but potentially we can do. And you can use it for the projects, mostly for the newer projects, right? If you have a large WebSphere-based Java web application, probably you will not be able to convert that to a native image. If you start a new project and if you write a small Spring, I don't know, some small Spring-based or Ktor-based application, then you probably will do. So native image, it starts really fast. It doesn't need that much memory. It doesn't use CPU at the time of execution. So you can see the red ones are the CPU usage. It only does that when it actually serves the request. You can also tune that, how much memory it uses. There are a number of microservices frameworks on the Java side, because I don't think very many people in the Kotlin ecosystem actually had looked at that. But I think Ktor works as a native image as well. So a number of options that you can use, a number of options that will give you the same benefits. So the startup in milliseconds, the memory footprint in megabytes rather than hundreds of megabytes. And with the current thing is that there is currently an issue with Kotlin coroutines with loops inside them. The GraalVM compiler cannot represent them well on the internal data structure level. So currently it kind of is slow in the JIT mode. And currently it just bails completely in the ahead of time compilation mode. But we are going to work on that. I talked to people yesterday because I wanted to figure out why this is happening still. Really, in May when I submitted this session, I really hope that we're going to fix this by the conference. But we were dealing with other things and currently not, that is still outstanding. But I think there is a technical solution that would work. It's just like we need some time to look into that and actually like make it work, right? But it's not a showstopper that it will never be supported. Actually, to be honest, like it also can be fixed on the Kotlin side, right? It's not just us. But it will have different trade-off, like impact trade-offs, right? So it could be better if we could fix this rather than Kotlin would change the code generation patterns. But we're working with those people, so we're going to fix it. And eventually, we would like to run the ahead of time compiled mode, kind of with a very similar peak throughput to the JET. So for the best performance, what you would like to do and what we would like you to do as the runtime implementers, don't try to cheat the system and just like write code as you normally write. Specifically, try to write small methods because the compilers are great at inlining them. So if you write small methods, we can inline them in different combinations. If you write large methods, it's very hard to kind of like pull the parts away from it, right? Which compilers can still do that to a little bit of extent, but like it's awkward. So small methods, good. Large methods, less good. Don't hand optimize your application, right? So try not to introduce those like code patterns that you think, oh, this is for performance reasons. If you want throughput, try GraalVM in the JIT mode. If you want the memory and startup, try GraalVM native images. GraalVM ecosystem is quite large, right? There are a number of components which are production ready and which we think are production ready. That includes the native image compilation. There are a number of experimental and a number of components which are even at a less than experimental phase currently. But you can see that we have a pipeline to kind of become a proper runtime for all languages. So Twitter is currently using us for their Scala workloads. They're using the compiler specifically, but it's us. Oracle Cloud recently started using the GraalVM, and they saw good numbers, specifically on the garbage collection times, so they improved the pauses very much. There is a collaboration between Oracle and NVIDIA for creating a language on top of GraalVM that will expose GPU kernels. So if you're interested in running something with GPU, but you never figured out how to use that from Kotlin, maybe you could use GraalVM. We can run Node applications normally. Our JavaScript is top-notch compatible. Our JavaScript is as compatible as recent Node implementations, which is a very good feat because JavaScript as a language, it's a very fast-moving target. So being compatible is good. We're also, other languages are a little bit less compatible with the existing ecosystems, mostly because of the native extensions, right? When you write in Python and you see something is slow, what you do, you rewrite the inner loops in C to make it fast, right? So we don't do that in Java. We don't do that in Kotlin because the platforms are plenty fast normally. Sometimes we do, to be honest, but like normally we don't do. And it's a much more established practice in the dynamic languages. Our packages or Python packages, you can check the compatibility on the website. We define that we take the packages and we run their tests. If the tests pass on the GraalVM as a platform, we think that we, as a platform, do everything that the package wants us, right? Because the tests pass. So you should try that. If you want, you can figure out how to get into the product relationship and maybe consider the Oracle GraalVM Enterprise Edition, which is an official product, which I personally think it was a great feat that we could release that in this May, because it was not easy to finalize it as a product. Maybe it's a little bit less ambitious than JetBrains Space in the functionality, but it could be maybe a very good platform for running JetBrains Space, right? But you don't have to actually buy anything. It's an open source project. What you can do, you should download it, you should use it, you should try it on your code, you should talk to us, you should try mixing your Kotlin with some other languages. I have 3 minutes and I have one short demo about this, and I'm going to show it to you in a second. So try it. We would like to hear the feedback. We would like to hear the performance results from you trying it on your workloads or similar workloads, because currently I think before this we didn't have a lot of exposure in the Kotlin ecosystem, right? So we would like to see those numbers. Well, I have a good hope that we will show quite a speed up on Kotlin code for the same reasons that Scala gets speed ups, right? If you have colleagues who write Scala, how many people know people who write Scala? Very good. Point them towards the GraalVM. We have good results for Scala as well. How many people know people who write Node.js? Very good, very good. We cannot run JavaScript faster than V8 yet, but you can share the joy of having Kotlin libraries offered to them. So if you have to work together, if you have, for example, a Kotlin backend application and it uses React as a front end, and you would like to use the server-side rendering for React, right? Normally what you do, you'll set up another node process to render with React, and your node and your JVM will talk at the backend, burning CPU, right? So you don't have to do that. You can render your React application from your JVM, from your Kotlin application, and it will use your facilities normally. So I have just 1 minute here, and I'm going to show you this particular application because I recently learned how to do this, and I think it's mighty cool. So I have this Kotlin code, and I have this suspend function, right? So it will take the coroutines and everything. And in my main function, what I will do, I will try to establish the JavaScript builder, and I will try to execute that function, right? And that's going to work. Who thinks it's going to work? Yes, of course not. Of course not, because that function is a suspend function. So on the bytecode level, and as a JVM, like it works on the bytecode level, this function has 2 arguments, because there is the coroutine context that you have to pass to make this work, right? And your JavaScript doesn't know anything about the coroutine. So what we should do? What should we pass here? What's a notorious object in the JavaScript? No, there is backend. There is no window. Of course, undefined. So we're going to pass undefined from JavaScript engine to our Kotlin coroutine function, and we're going to see and try to see what it has, what it does, and it creates the Kotlin null pointer exception. I was told that Kotlin doesn't have null pointer exceptions. You had type null safety and whatnot. And to be honest, I was informed that in the recent releases, this was renamed just to null pointer exception to hide its, I think, to hide its relation to Kotlin. But no. So now, for people who have colleagues writing Node.js applications, you have a runtime to offer them the happiness of working with code that can produce Kotlin null pointer exceptions. Thank you very much. I actually let me don't do this. Don't clap yet. To make this work, you have to generate an async bridge, right? So that will just be a normal method, and it will enter the coroutine scope for you, right? So if I do this, and then I would do hello, and then I will do get because it's completable future, this should produce me the result. This should pause for a second and then produce me the result of hello. Fingers crossed. Yes, result of hello. Excellent. So this way you can run it. Thank you very much. If you have questions, come to me, talk to me, find me online. It was very happy to see you here. Thank you.
Hi, everybody. My name is Sebastien Deleuze. Today we are going to talk about the state of Kotlin support in Spring. I'm a Spring Framework committer, and I'm also responsible to the Kotlin support, so I have done most of this work. And I'm going to share that with you today. First, I'm not here to give any lessons, but I tried something new this year. I tried to come from Lyon in France here to Copenhagen in train. That was a pretty long trip. In fact, that was 2 days with a lot of surprises, like a whiteboard that was hit by the Thalys. So my first connection was missed. So with Louis CAD, we spent two days in the train towards Copenhagen. But we had also nice surprises, like getting the train into a boat to cross the sea. That was pretty unexpected. So my message is just, sometimes you don't even ask yourself the question. Myself, each year I go to Barcelona from Lyon, and I was using flights because I was just not asking the questions. And it's in fact 5 hours just in the train without security control. I can use my laptop during all this time to work, and I'm arriving directly in the city. So just maybe ask yourself the question in terms of climate that could make the difference. So the real topic, why Kotlin? That's my opinion, obviously. I think Kotlin improves the signal-to-noise ratio compared to Java. So I think it's super important to express our ideas and algorithm with something which is easier to understand. The safety, and especially the null safety feature, is a pretty clever feature. It's allowed to turn Java billion-dollar mistake, and I think it's in fact much more, into a powerful feature that allows to deal with the absence of value. And the trick is just to deal with null in the type system. And that's what Java is not doing, and that makes a lot of difference. The discoverability is also super important. I mean, you are all using APIs, new APIs are coming, and it's super important to make this API discoverable. I'm lazy, I like to use control space to discover new things, and I prefer this way rather than conventions or things that you need to know before using your framework. The pleasure, I think it's important. We mostly use Kotlin, I guess, for work, but we spend so many time in that's super important to have pleasure, and I have much more pleasure using Kotlin than Java. And the Android ecosystem is also huge, and it's coming to Kotlin very fast. Obviously, the server side is moving slower, but I think the Android ecosystem could have an impact on the server-side one, just given the number of developers. Sometimes some mobile developers do server-side things, not that much, but it happens. And maybe later we could see similar stories with the front end. So Spring loves Kotlin, and I'm going to try to show you how much. So at Spring, we love so much Kotlin that we have decided to translate all the framework's reference documentation from Java to Kotlin. Concretely, that means that for each code sample in Spring reference documentation, you have now 2 tabs, one Java tab, which is obviously still selected by default, but you have also the Kotlin tab, and it's not just a one-line-to-one-line translation, okay? It's when an extension is available, when a DSL is available, it's shown in the Kotlin code sample. So it's not just automated translation. I did the translation sample by sample, and it's idiomatic Kotlin used in Spring. So I think that's a good way to learn Kotlin and to learn what is the idiomatic way to use Kotlin in the context of Spring. So this is available in Spring Framework 5.2 documentation. So you just have to go to the current reference doc, and you will see that. I have tried to summarize what is the current status and what are the next steps with this kind of table. So obviously, translating the Spring Framework documentation was a huge work, so many hours. Next year, we should be able to provide the Spring Boot documentation translated as well. And if you want to help, that could allow me to focus on other features. So if you want to help translating the Spring Boot documentation, it's not that huge. It's smaller than the Spring Framework one. And the work has already started via community contribution. So if you want to help, feel free. Spring Security will have Kotlin documentation as well. And Spring Data is a pretty huge project with, I think, 17 sub-projects. So some part of Spring Data may have Kotlin documentation, some part not. Another thing that we have done to increase the Kotlin support in Spring ecosystem is to provide Gradle Kotlin DSL support on start.spring.io. So since a few months, when you start a Kotlin project with a Gradle build system, we will automatically use the new Kotlin DSL in the project that is generated. So feel free to leverage that. More DSLs. So Spring MVC is provided with mock MVC DSL, which is a pretty nice one, but it's not super discoverable. It implies a lot of static imports. It's Java-ish. So again, via community contribution, so thanks to Clean Checkets and Jean-Baptiste Nizet, we now have a mock MVC Kotlin DSL that you can trigger by using this kind of mock MVC.request extensions. I have tried to identify all the extensions in these slides by highlighting them in yellow. Okay. And when you use this kind of extensions, it triggers the use of the mock MVC DSL, and it allows you to describe that in a more Kotlin way. We have tried to stay pretty close to the Java one. Okay, so if you know mock MVC in Java, it's not a totally different thing with just Kotlin idioms. We have tried to find the right balance between something idiomatic in Kotlin and something which is still close to the Java API. Team from Pivotal has also contributed a Spring Cloud Contract DSL, so feel free to use that if you are using Spring Cloud Contract to test your APIs. And I'm always happy when somebody else than me creates some Kotlin features in Spring ecosystem. So big thanks to Spring Security team and especially Ria Stein, who has done an amazing work to introduce Spring Security Kotlin DSL. So Spring Security is configurable with a Java DSL, which is pretty extensive. And the Spring Security team has created an official Spring Security Kotlin DSL, currently in experimental mode, available at this URL. And next year, it should be integrated by default with Spring Security 5.3. Another big part of the work in Spring Framework 5.2 has been to introduce the router DSL and the functional API for Spring MVC. I don't know if you have seen the previous presentation I did, but basically with Spring Framework 5, we have introduced a new way in addition to add controller at request mapping to write your web components via a functional API and via a Kotlin DSL. It was previously available only with Webflux. So basically to use this kind of DSL, you have to switch to reactive. So now we provide this DSL for both Spring MVC and Spring Webflux. So the DSL is very similar to the Webflux one. You are writing your handlers with a server request input parameter and a server response answer, response, return value. You have this API to define the status codes, the body, use the converters, everything that you can do with Spring MVC with annotations, you can do it with this kind of API. You can define the router. So here we have a distinct router and handlers, okay? And the router usually refer to the handler using callable references. And you can expose the router to Spring Boot simply by returning the router DSL return value and exposing it as a bin, okay? And Spring Boot will automatically take in account these routes. If we have a look to a more realistic handler, you will typically create a dedicated class where you inject your repositories, where you inject your services. Obviously, in Kotlin, we always used a constructor-based injection. And you will create various handlers. And you will create your router, defining your routes, and using callable references to reference these handlers. You can create how many routers you want. It's not monolithic. You can create any number of router. You can see it support nested predicates. You can create your own request predicates, so it's super extensible. And you can even create routes dynamically, and that's pretty important. It's not just syntactic sugar or a more Kotlin-ish way to write your web components. It also provides new capabilities because annotations are statically defined. So if you need to create routes depending on something which is in your database, which is not uncommon if you create CMS or e-commerce, and obviously you need to take care about caching and things like that. It's not as easy as it is here, but it's open new capabilities, and I think that's a pretty interesting way of writing your web components. So status updates. So Beans DSL and Webflux Router DSL are supported for quite a long time now. Spring Boot 2.2 brings the coroutines router DSL. We are going to see it just after that. The Web MVC router DSL, the Mock MVC DSL, and the Spring Security DSL is available in experimental mode. And next year, all these components should be available in production. Obviously, that's estimation. If there is a missing green thing next year, yeah, it may happen. So coroutines. I guess you have heard quite a lot about coroutines. I mean, there is a talk from Roman Elizarov and various other ones. So I will not go too much in detail, but I would like to share my view of coroutines from a Spring point of view and a server-side point of view. So coroutines are lightweight threads. You can create hundreds of thousands of them, while you can create less threads, basically. So it provides you a building block that allows better scalability and allow new construct, especially if you deal with asynchronous calls and application with a lot of I/O, which is typically the case on server side. The foundations are in Kotlin language, but unless other technology, there is a very small part at the language level, and most of the implementation is at kotlinx.coroutines. So when you talk about coroutines, be careful about defining what you are talking about. Maybe you are talking about these lightweight threads. Maybe you are talking about the language feature. Maybe you are talking about the library, which is pretty extensive and contains a lot of things. So I have seen that usually people talk about coroutine, but sometimes refer to different things. Coroutines, from Spring point of view, allow to consume Spring reactive stack with a nice balance between imperative and declarative style. Obviously, we have a huge investment in reactive APIs in Spring, okay? But I think there is two levels. There is all the stack that we are building, so all the reactive infrastructure. We have built Webflux. We are currently working on R2DBC, which is reactive SQL, and the GA has been released just a few days ago. We are working on RSocket, which is a way to bring reactive outside of the Java or the JVM and discuss with mobile or front end in a reactive way. So we have really a huge investment on reactive, and obviously coroutines compete with Reactor, for example, at API level, but that's not an issue. I mean, our reactive core is already designed to be exposed to Eric Java, for example, or others reactive or asynchronous API. So coroutines is just a new way to consume our reactive stack. So with coroutines, operations are sequential by default. Concurrency is possible, but explicit. And I think with coroutines 1.3, there is 3 main building blocks you need to know. There is, in fact, more pieces in coroutines, but if you just need to learn 3 things, I think this is the one I'm going to show. The first one is suspending function. So this is the basic block here from the beginning. You are writing your function, you add this suspend keyword, and it allows you to call asynchronous operation. So here I'm using a useless delay suspending function, but imagine that you are calling an HTTP client that requests remote data, or maybe a database that provides coroutines API. And so yeah, that's it. So this suspend keyword allows to define what functions are suspending and are designed to request data asynchronously. An important design point is that suspending functions color your API. Why that? What that means? That means that you have regular function and suspending function. Other technologies, ongoing technologies like Loom, for example, take a different approach. But here, you have a distinct kind of functions. Suspending function can call regular functions, but regular function can't call directly suspending function. You have to use some dedicated capabilities to do that. So that's not necessarily a bad thing in terms of design, but that's a thing you have to need to know. In that point, it's pretty similar to reactive and asynchronous API, where you are using wrappers like Flux, Mono, completable future. You have 2 different worlds, the regular functions and the coroutines ones. Another building block is structure concurrency. structure concurrency allow you to define asynchronous boundaries, because when you are writing asynchronous code in an imperative fashion like that, so I have just taken the example from Roman Elizarov blog post. Here, we want to load 2 remote images, okay? And we want to take care about what happens when one image loading is in failure. I guess the behavior that we want is that both image loading are cancelled and we throw an exception. And we have to define this kind of asynchronous boundaries like we define transactions from databases. So structure concurrency provide building blocks like coroutine scope that allow to define asynchronous boundaries to make coroutines aware about what to do when there is an error and define this kind of behavior. The big feature of coroutines 1.3, and I have pushed a lot to getting this type, and I will explain why, is flow. So flow is a new type available in experimental mode from coroutine 1.2, available in non-experimental mode for the base API in coroutine 1.3. And here I'm referring about kotlinx.coroutine.flow.flow, not the flow type which is in Java 9+, which is a kind of container type for reactive stream interface. So it could be a little bit confusing, but yeah, flow is a very attractive name, so both Oracle and JetBrains like it. Coroutine 1.3 so introduced this new reactive type, and it's super important because flow is the equivalent of flux in reactor world or flowable in Eric Java world for coroutines. And when we do the exercise to see if we could translate our reactive API to coroutines, so okay, suspending functions are great for translating mono, but we were really missing something for the streams. And I don't like channel. I don't think that's a good building block for building server-side applications. So we really miss that. And I'm glad to coroutine teams that did an amazing work to provide flow in time for Spring Framework 5.2. So flow does not implement directly reactive streams because it is based on coroutines building block instead of regular Java construct. But it can have some of the semantics and behavior of reactive streams, even if not totally, and it provides some support for back pressure. Sorry, there is a lot of different words, but I will give you pointers about more detailed talk to learn more about back pressure, air socket, etc. later. But back pressure is basically a way for a consumer to not being overwhelmed by a very fast producer, okay? So it's a way for the consumer to say, okay, you can send me 10 chunk of data, I will process that, and the sender will only send 10 chunk of data, not more, and that allow to have scalable application at the level of an architecture. So Flow API is like that. Flow API provide a collect suspending method with a flow collector that itself provide a suspending emit method, and that's it. So the building blocks, the root API is super constrained, and operators. So when I say operators, it's similar to operators that you have in Eric's Java or Reactor world, okay? So filter, map, zip, etc. Are provided as extensions, and some of them are pretty easy to implement. In reactive world, Eric Java, Reactor, if you want to implement a reactive operator, I guess you have to be Stéphane Maldini or David Karnock or Simon Ballet to be able to implement that. Myself, I can't, sorry. So what I mean to say is that it's pretty hard to implement your reactive operator, very hard. In coroutines, it depends. It's not always easy, okay? So if you don't have any concurrency involved, I would say it's pretty easy. This is the real implementation of the filter operator that is built in with the coroutines API. If you are implementing operator with concurrency, it's much more easier to be from the Kotlin team. But at least it's possible. When you want to create a flow, you will use this kind of flow builder. You can see that the code inside it is pretty imperative, okay? You just use a for loop. you can call any kind of suspending function inside the flow builder. So if you want to request remote data from your HTTP client or with database, you can do that. There is no limitation because this flow builder takes a suspending lambda. So basically, that's a lambda which is suspending, and inside the lambda, you can call any kind of suspending function. So here, I'm just emitting a number each 100 milliseconds, and that's it. So when you consume a flow, it's more declarative, it's more functional. That's why I'm not okay when we say with coroutine 1.3, reactive is declarative and coroutines are imperative. I think that's wrong. I think coroutines 1.3 provide, again, a nice balance between imperative and declarative. This is declarative. And inside the operator, like map, you can use more imperative constructs. So I like this balance where you can use imperative code where you retrieve a single asynchronous value, and you can use declarative functional approach when you want to describe how you process streams of data and things like that. And I think that's a perfect balance. So what about Spring support for coroutines specifically? So Spring provides official coroutine support for Spring Webflux, Spring Data, Spring Vault, and our AirSocket support. On Spring Data side, we support Redis, MongoDB, Cassandra, and R2DBC. And R2DBC is reactive SQL, so we provide support for PostgreSQL, H2, MySQL, Microsoft SQL as well. And there is no new types introduced because I'm lazy and I don't want to duplicate all the Spring API. So we provide seamless support with the annotation programming model. That means that with Webflux, not Spring MVC, not for now, that will come later, you can add the suspend keyword in your handler methods, annotated with @request mapping, @get mapping, etc. And that will enable you to call any kind of suspending function, any kind of coroutines API inside this handler. So conceptually, this is like a function that returns a mono of banner, okay? If you are using Reactor or a completable feature of banner, it's just that you don't have to use this wrapper, you just use suspend keyword. It also works for suspending view rendering, obviously. And for functional APIs, we provide coroutine support via extensions. So basically, we provide various reactive APIs. So web clients is our reactive web client, okay? And it natively provides methods like body to flux to return a flux of something, body to mono to return a mono of something. And what we have done in order to avoid duplicating the whole API is just to provide extensions like body to flow, like await body, that allow you to provide coroutines API without any reactive parts involved. I mean, without reactive API directly exposed, and that allow you to get flow or suspending function and deal with all the reactive capabilities underneath in a coroutines way. So yeah, that's our strategy. We provide such support also for Webflux router with this kind of extension. We provide support for AirSocket. So again, AirSocket is a way to be reactive between, for example, your server side and your mobile application. And I think AirSocket has a huge potential on Android, but that will be another talk maybe next year. You have this kind of retrieve flow. You can use all the flow operators. So basically, yeah, you can think about it as every reactive capabilities in Spring is exposed in coroutines in addition to being exposed as Reactor API. We even support coroutines transactions with databases. So we have worked a lot on the R2DBC support. So again, R2DBC is reactive SQL. So we have this, so database client is a kind of fluent API for R2DBC. It's totally possible to have some part of the Kotlin ecosystem that leverage R2DBC because R2DBC is really has no dependency except reactive streams, okay? So it's totally possible for exposed or any kind of pure Kotlin API to leverage R2DBC API without any single piece of Spring involved. So here I'm using Spring Data R2DBC, which is our way to expose R2DBC by default. But R2DBC is really designed as a very low-level thing that that is totally usable in another context. And I really hope that the Kotlin ecosystem will leverage all the work we have done at the driver level, because really exposing R2DBC as coroutines is just using a single extensions. There is almost no performance loss, and I think that's a good opportunity for Kotlin and coroutines ecosystem. But here I'm using the Spring capabilities, so I have this transactional operator, which is kind of functional transactions, and it allows me to define the transaction boundaries using a reactive stack. There is also a .transactional extension that applies to Flow to use transactions on top of the Flow type. We provide support for Spring Data, reactive MongoDB support as well, and various other things. So coroutines are now the default way to go reactive in Kotlin. I mean, it's perfectly fine to use Reactor API if you want. Just, I think people are waiting some kind of guideline and opinions. So my thinking is that when you are leveraging the reactive stack in Kotlin, it's very likely you would like to use this coroutine API. And so when you select on start.spring.io Kotlin and one of the reactive dependency, the coroutines dependency will be automatically added. So you don't have to add another dependency manually. And in the reference documentation I have created, by default, all the reactive examples are written in coroutines and not exposed with Flux and Mono. So yeah, that's basically the default way to consume. If you agree, I hope you do. In terms of scope, so we have plenty of things already supported. Stream Reflex functional APIs, web clients, the annotation programming model with at-request mapping, AirSocket at-message mapping, Spring Data reactive APIs, and functional transactions. What is missing is Spring MVC at-request mapping, because Spring MVC has some support for Mono, and also for Flux. It's less advanced than WebFlux, but it's possible. So I think Spring Framework 5.3, Spring MVC in Spring Framework 5.3, Spring MVC will support coroutines as well. That's pretty useful when you want to use web client in Spring MVC, and obviously that's a missing part. Spring Data repositories will be supported because Mark Paluch has already implemented it in less than 1 day, so hopefully he took care of that. And add transactional is not supported yet, but I hope we will be able to support it as well. So for now, you have to use functional transactions. Okay, Spring Boot. So what are the new features on Spring Boot side? This is the kind of configuration properties I was writing last year. Configuration properties are a way to expose in a type-safe way your properties that you write in .properties or .yaml, okay? And since it was not designed to be used with immutable classes, we had to use this late init var, and I was crying every time I was writing that. So now we have this add constructor binding annotation that allows to instantiate configuration properties by constructor, okay? With full immutable support, read-only properties, and we don't have this kind of crappy late init var. And we can just use a class or data class with read-only properties. So feel free to use that. Another useful thing in the context of Kotlin is that start.spring.io now have 2 new buttons. A button Explore that allow you to directly have a look in the GUI about the generated project. So that's avoid to generate the zip, extract, have a look, etc. So that's pretty useful. And another which is share, which allow to share the current configuration. So if you go to start.spring.io, you select Kotlin, Gradle, and you want to share that to your coworkers to increase the Kotlin reach, feel free to use that. I keep forgetting this kind of URL, which is supported for 2 years now. So now you have an easy way to get this kind of customized link. Kofu. So Kofu is another topic, and Kofu is experimental. So until now, I was speaking about production-ready stuff. Now we are entering in the dangerous land of the experimental stuff. So Kofu is basically the application DSL, okay? So we have seen router DSL, there is a beans DSL, there is mock MVC. We try to not do too much DSL, but it was tempting to do an application one, and I will explain why. Spring Boot's main design is around conventions. So basically, with Java is too verbose to define explicitly things. So Spring Boot provides conventions, and I think that's a pretty widely used and accepted model to configure Spring Boot, and that's perfectly fine, and there is nothing wrong using that in Kotlin. But since we have this great DSL support, and since we have all these other DSLs, it kind of makes sense to try to see what that means for Spring Boot to have a configuration with the DSL. And the interesting thing is that it's explicit configuration. So you won't have Jackson support that pop up because you have a transitive dependency that brings Jackson, because that's how Spring Boot currently behaves. It's based on conditions that could be triggered on properties, on classes present on the class path and various things. And if you are a control freak like me, you will maybe lack this kind of thing. So it's experimental, so don't use it in production yet. It leverages existing DSLs like beans, router, security. And it provides composable configuration and discoverability via autocomplete instead of convention. To me, that's just a detail, because I think with the upcoming Spring Boot version, we should be much closer to Kofu performances, even with the annotation variant, but it currently provides faster startup and less memory consumptions. Currently, we have a decrease of 40% of the startup time and less memory consumption when you configure your Spring Boot application with Kofu instead of auto-configuration. But again, I tend to think this gap will be reduced by the work we are currently doing. So that's not the main point. The main point is about getting explicit configuration for that. So a quick demo. So Spring Boot 2.2.2 is expected to be released during my talk, so we are going to see. I have not tested with that one. Okay, still 2.2.1. So I'm just going to create a regular Spring Boot application. So it's important to understand that a Spring Boot application configured with Kofu is just a regular Spring Boot application. So you still create it via start.spring.io. Okay, so I'm going to Spring Foo website. So it's on Spring Project Experimental. Okay, and going just to copy and paste that. So I'm adding the Milestone repository. Okay, I'm adding the Kofu dependency, so it's just a regular dependency that provides the application DSL. Going to import the changes. And if everything goes fine, I should be able to use my application DSL. So I remove that, I even remove that, and I will create my application. So, okay, so I'm going to create my application. Here I'm going to create a Spring MVC application. So I'm select the servlet type. And then I have access to a DSL where I can configure things. So for example, I want to add Spring MVC support. I'm going to leverage my router, okay, and I'm going to create a route which will just return OK status and return a body with hello KotlinConf. So then I will just, everything is explicit, so I need to run this application like that. And that's it. So it's really a way to leverage existing things. This router DSL is exactly the one that is provided with Spring Framework, okay? But here, I'm reusing it in a context of a functional, an application configured with a functional style. So, okay, super. Then if I want to add some kind of Jackson support, for example, so let's say I'm creating a class sample, val title. Okay, and I want to return this class and serialize it with Jackson. In Spring Boot, it's automatically configured. Here, since the support is explicit, I will have to, but that's on purpose, declare. So you can see, in terms of when I talk about discoverability here, I can just see with autocomplete what are the various converters without having to read the documentation. So here I'm using Jackson. If I want to configure pretty print, again, I'm lazy. I have not a very good memory, so I have just to use my autocomplete to enable the pretty print option, and I can discover all the great options that are available in Spring Boot to configure Jackson. So it's really a way to expose as a DSL, in the discoverable DSL, what you can do in Spring Boot. So I'm going to see that. Okay, and I have not much time, but a very important point is that you can create modular configuration, and that's one of the main purposes of this kind of construct, is that it's not monolithic, otherwise it will be not super interesting. You are going to create web config configuration. We are going to define logging configuration like that. Okay, and then you select explicitly what you enable, because again, everything is explicit. You are going to select this kind of config, this other one. And if for your tests, you want to only select, let's say, the web config, but not the data one and mock other things, you will just declare a new customized application just for your tests that will trigger and run just what you need, so faster integration test and things like that. So I have not the time to describe everything today, but I guess you can understand the potential and the philosophy. So you can find more on Spring Foo, and I will continue to evolve it. Feel free to give feedback. Not that much about the scope of the support, but more on the root principles. And my goal is to make a Foo the Spring Boot Kotlin DSL integrated in a production-ready way. We are not here yet. I think the current step is really have more Kotlin market share in regular Spring Boot applications. So it's kind of chicken and eggs issue, but I need more people using Spring Boot in Kotlin in order to trigger the pretty big work of exposing every Spring Boot configuration features as a DSL. And the last topic is GraalVM native support. So there was a nice talk by Oleg just before me in this room. Okay, so GraalVM native in one slide. That's a way to compile your Java, your JVM application into a static executable. It provides different characteristics. So instant startup time, very low memory consumption for small application, smaller container image because it allows you to create from scratch Docker images because you can create executable statically linked. But it's also still required to use OpenJDK on development side, so that's not super consistent between dev and prod. In terms of maturity, in terms of throughput, we are not at the same level as OpenJDK. So what I just want to say is that it's an interesting platform, very different characteristics. It could allow to lower the cloud hosting costs, but it also comes with a lot of drawbacks and different characteristics. So be careful and evaluate all the criteria. We are going to work on some dedicated out-of-the-box setup capabilities for Spring Framework 5.3. The work is currently happening in Spring Graal Native, so feel free to have a look. And Kotlin is supported, so I think I have something. yeah, so I will not compile it because compilation is take quite a lot of time, so something like 1 minute currently. We will try to make it faster, and we are collaborating with the GraalVM team to decrease this time. But when you, so I am cheating and I already compile it, and you will see that it allows to start your application pretty fast. So yeah, you can start basically your application almost instantly. So it's allowed to perform to create scale to zero application. That means that your application, imagine that you have a back office that is used 10% of the time, and you have deployed that with a very nice 20 microservices that are running every time, and you are running 40 instances because you want high availability. With this kind of mechanism, each instance of microservices will consume less, and you can basically shut down the service when it is not used, at the cost of a lot of other constraints, and not all the ecosystem is supported, and it's still super early, so be careful. But we are interested in that, and we are working on such support. And it's working with Kotlin, except for coroutines. So coroutines, there is an issue with coroutines that should be fixed in the upcoming months. We have discussed that last week with the GraalVM team, and it should be possible to fix it in the upcoming releases. So I have talked about a lot of topics. If you want to start thinking more slowly by the beginning, there is the official Spring Boot Kotlin tutorial, which is continuously updated. So this is regular Spring Boot, Spring MVC, annotation, GPA, nothing fancy. So start by that. I think that's a good resource. There is my 2 talks at Devox. The first one is a 2 or 3 hours deep dive about coroutines with Spring, about AirSocket, about R2DBC, which much more detailed than I was able to show today. And there is a dedicated GitHub repository with the front end in Kotlin.js, which is another topic, super interested in that topic. I was not able to detail it, but you will have more detail in my talk. And the other talk is about Spring Boot, running Spring Boot application as GraalVM native images. So if you want more details about that and learn more about GraalVM native in a kind of neutral way, so I have tried to show the advantages of the platform and the drawback in a kind of balanced way. Feel free to have a look at this talk. And thank you a lot, and remember to vote. Thanks.
Good afternoon. Hello. So my name is Pamela Hill. I'm from a very sunny South Africa, which is a little strange to be in a very rainy Copenhagen. But we have 11 official languages in South Africa. But I'm not going to greet you in every single one of them, but rather just in one. In my mind, it's the most beautiful one. And it's a Zulu greeting, Sawubona. It means, I see you, you are important and I value you. Thank you for coming to my talk. So my talk today centers around a project, which you might have guessed from the title of my talk, is a full stack web app written in Kotlin. And we'll be going through how I created this talk layer by layer from back to front end. So my project is a vision board, and it's called Life Visualizer. Now, according to Wikipedia, the source of all truth, a vision board is a collage of images and photos and affirmations of one's dreams and desires, designed to serve as a source of inspiration and motivation. How does it work? Well, let's have a look. Right. So we're going to start by registering a user. I just want to see that this is playing. No. Pardon. I just want to check that this is playing. Okay, I'll just talk you through it. So what we start by doing is we register a new user, and then we go through to I think it might play now. We go through to a little screen where we can add some inspirations, like you can see over here. So then we search for something that's interesting that we want to make our life goals. And that would be something like cuddle a cute cat. That sounds like a life goal, right? So I use an API called Unsplash to select to find some nice images that matches a keyword cat. And then I create a little inspiration by it. You can see it in the middle at the bottom. My next inspiration was to see the Northern Lights. So what I go ahead and do then is I select the picture, I add some tags to it, and then I create that inspiration. And then I do some filtering on it. It was very impressive. I'm so sorry you can't see it. But this is what a completed life visualizer will look like. So I want to see the Northern Lights. I want to visit Rome and Barcelona, and I want to move to Cape Town, because I'm from a very small, weird town called Pretoria. And I also want to meet my boyfriend Sean's cats, and I want to go shark cage diving, because that's a thing that people do in Cape Town. Right, so let's have a look at how all those moving parts fit together. Now, starting from the bottom, we have a web app written in Kotlin.js, and it uses the Axios library to connect to some REST services on a Ktor server via HTTP. And that Ktor server connects to that API, the Unsplash API, that provides us with images. They're nice and high quality, but royalty-free. And that Ktor server uses a Ktor client, just for variety, to connect to the API over HTTP. The Ktor server also saves some user data. So we save that into a H2 database through the exposed library. But the purpose of my talk isn't just to show how to build a full stack web app. I could do that, but that sounds a little bit boring. So my project also has a philosophy behind it, and it's the philosophy of beautiful code. But that's a pretty vague concept, right? Yeah. So Ward Cunningham, a very famous programmer, actually made a statement about beautiful code that might clarify what I mean by it. He said, you can call it beautiful code when the code makes it look like the language was made for the problem. And one of the many ways in which Kotlin shines is the way that it allows us to create beautiful code and beautiful DSLs. So not only are we going to be we're creating this full stack web app, but we're also going to meet and say hi to some really beautiful DSLs along the way. I just want to quickly align with everyone. Everyone pretty sure what a DSL is? Just show hands. You know what a DSL is? Okay, that should be everyone. Just a quick recap. It's a domain-specific language. An internal DSL is written in Kotlin, but it's still a DSL. A normal DSL would be SQL or regex, whereas an internal DSL is the ones that we're going to be looking at today, is written in a general purpose language. But why would we want to use DSLs? Well, firstly, DSLs are declarative, so they're really focused on describing a problem or the solution rather than how to get there. So they're also super, super concise. Great DSLs can be very readable, and some Kotliners call this fluency, reading almost like natural language. Good DSLs also make it very clear what the original author intended to do, so the original developer. And that makes it easier to understand and adapt our code to new requirements without introducing some extra bugs. And while that's not all there is to maintainability, it's a really great place to start. So what makes Kotlin a great language for DSLs? Well, Kotlin helps us, and this list was actually presented by Venkat Subramaniam at the last KotlinConf, so kudos to him. Some of the language features that support creating those fluent DSLs are the optional semicolon, which removes a lot of syntactic noise. Infixing functions that improves our readability, not requiring that last parentheses around our last lambda argument, also removes a lot of syntactic noise. Operator overloading using conventions, which gives us a nice shorthand notation. Extension functions that make our existing code more fluent. And maybe two relatively unknown language features, lambdas with receivers and the invoke convention. Just a quick show of hands, lambdas with receivers. Anybody know what that is? Okay, we will be going through that quickly. Because it's actually a very important way of understanding how most DSLs are constructed. So my one friend always says, when she hears lambdas with receivers, she always thinks llamas with hats. And I'm like, that is the most absurd thing that I've ever heard, but okay, llamas with hats. So lambdas with receivers are lambdas that are executed within the context of a receiver. What does that mean? Well, it's a lambda that has a receiver object. And the receiver object is inside that method implementation is represented with this context object. But it's always nice to have a look at examples, so let's have a look at one. Say that we wanted to create a lambda with receiver where we want to determine whether the integer is even. And that's what the type would look like. We have an int receiver, we don't take any parameters, and we return a Boolean. Inside the implementation of this function, or lambda, this context object refers to the int receiver. And we just do our normal old calculation of the number modulo 2 equals to 0 to determine if it's 0. And when we want to call this lambda, we just use the regular old way, which is very fancy if you're in Java. But for us Kotliners, this looks a little bit like an extension function, but it's actually a lambda with receiver. So on to our next section. So we will be going through Ktor, Exposed, and also the Kotlin X HTML as DSLs and building everything step by step. So we start with Ktor, which is a Kotlin framework for creating asynchronous servers and clients. It's nice and open source, but it is created and maintained mostly by JetBrains. For Ktor, we use a DSL and in order to create our application behavior. And it's also really, really easy to set up. We'll be looking at how to actually go ahead and set it up. But you can either use the IntelliJ plugin, or you can use the generator at start.ktor.io. Interesting enough, ThoughtWorks, which has a technology radar, and Ktor actually featured on this radar quite recently under the trial category. And it's been slowly making its way from, a very experimental, be wary of it, to something that's trialing. So in other words, try and use this project on a project that they can actually handle the risk, but it's probably a good bet. So this is what they said about Ktor. They said the flexibility to incorporate different tools in addition to its lightweight architecture makes Ktor an interesting choice for creating RESTful services. So let's have a high-level look at how the Ktor application is structured. So a Ktor application has one or more modules that are user-defined, and each module implements a part of the application logic by installing and configuring features. So a feature has a particular functionality that it does, and it intercepts some requests and responses, and then performs something, a little function. So examples of features include authentication, routing, logging, and content negotiation. Ktor supports HTTP 1, 2, and also WebSockets. And once a request comes in, it's converted to an application call, and that application call flows through a pipeline of interceptors. Now, this is what the normal interceptor pipeline will actually look like. We have a setup phase for preparing the call and its attributes for processing, and then a monitoring phase for tracing, features where most features are going to intercept the pipeline, calls for completing where most features and interceptors that actually complete the call will run, and also a fallback phase for handling unhandled calls. So this is how you can set up a project. I realize that it's probably not so easily readable. I hope it is a little readable, but this is what the website actually looks like. So let's go through it step by step. So creating the project is easy. You can either use the IntelliJ plugin and use it directly inside IntelliJ, or you can use this guy. So starting from the top left, we select our build system, which can be Gradle or a Gradle with a nice Kotlin DSL. I always sound like a chef when I say that, a nice Kotlin DSL. And also Maven. Don't use Maven. Then we also can then we select our server engine, which is Netty, Jetty, Tomcat, or CIO, which is Kotlin, which is Coroutine's IO, something from JetBrains. So then we select our Ktor version, which is currently 1.2.4 in stable. But if you're feeling a little adventurous, there's also 1.3.0 in beta 1. After configuring our Gradle, we go ahead and select some server features, which is going to be something like routing, locations, which we're going to look at next. It's a pretty exciting feature that allows us to do routing in a typed way, and also JSON for JSON serialization. Because we're going to be using the Ktor client in the Ktor server, we also use the HTTP client engine, and we also use some JSON serialization stuff. So let's have a look at how we actually create the application. So we need to do two things. We need to create the application module and set up the server. So because our application is quite small, I had about maybe 8 routes. We'll only really have one module, which I called Life Visualizer. And if the application is bigger, you're going to split up your application into multiple modules that handle separate areas of your application. So we create a module using an extension function on application, do some feature installations, and also do some routing. Then inside the main function of our application, we go ahead and create our server, which is based on Netty, listening on port 8080, and with our Life Visualizer application module configured in. We start the server, it waits for calls to come in, ta-da. Right. So our next task is to actually go ahead and install some features. We install the content negotiation feature and also routing. So let's start with content negotiation, which is going to do the JSON serialization for the app. We simply say install with a feature name, and then we configure that feature. Here we're just saying that we want JSON to be used as our content negotiator. Routing is automatically installed because we use Caterer mostly for routing. So we actually only have to configure it. So the way that we configure it is by defining some routes. And in order to define that route, well, we just say it's a get call and with a path. It's pretty simple, right? So let's zoom in on, okay, well, let me just tell you what the two routes are. The first one will get that selected amount of, like a sample size of images from Unsplash and return that based on some keywords. The second route gets a specific user's inspirations, life inspirations. And I wish that I could have shown you the demo because that would have clarified a lot. But, you know, the demo gods or whatever you want to call them. Right. So let's zoom in on that first route, because that's going to clarify how we do our route configuration. Okay, so we need to get our keywords query parameter from the request. So we use the call object to get that. But what is this call object and where is it coming from? Well, call is just a way of representing the request and responses. And it's actually just an extension property on that route configuration block body. So we use the parameters map to get the keywords. And then we check, did we get a nice client that sent us something through, or did they forget? So if the keywords is null, we use call to respond with a bad request response. But if the keyword is not null, we go ahead and search the Unsplash API with our keywords. We also then, if we get some results, we say, okay, the HTTP status is okay, and we hand the inspirations through. But if we couldn't find anything, if I typed in ASDF, I would get nothing from Unsplash, because what does an ASDF picture look like? Anyway, so then we would actually go ahead and get we would actually respond with no content. So this looks okay, but it can actually get better. So let's have a look at two refinements that we can actually go ahead and make on this piece of routing code. So our first refinement is locations, and all this manual retrieval of the query and the path parameters can result in quite a lot of boilerplate. So in order to minimize this boilerplate that we've got in a nice type-safe way, we can use locations. But note that it is still experimental, so you're going to get warnings all over the place. And the first thing we need to do, install locations. It's a typical pattern, install, configure. Next, we need to define the locations with @location. The annotation, and we also have our path. And we also need to create a data class that is going to hold all our parameters and things that we want to get from the request. And then the last step is to actually go ahead and use that data structure that we just created. So we get a specific data class or a specific data structure, and we template that get with that data structure that we just created. And inside that block where we actually go ahead and do the routing, we can refer to that generic template as it. Which might be a good thing or a bad thing, depending on readability. But you can use it to get to the keywords. And the rest is pretty much the same, but we've cleaned up the code significantly. Our next refinement is really for a little bit larger than toy server. So all these root definitions can quickly get out of hand. It gets pretty long the more root definitions you actually add. So it would be nice if we could split them into separate files, and we can. So each root is actually an instance of root class. And by defining an extension function on root, we can go ahead and put that in its own file. And then we just refer to that function from application. And then it's a really simple change, but to me, it made a world of difference. So let's have a look at how we actually get those images into our app. So first we have to register with Unsplash, which provides these amazing photographs. And we also need to describe our app to Unsplash so that we can get access to an access and a secret key. And most of the API was put behind some OAuth security stuff, but luckily not for the services that we call. We just have to pass on an auth header that has the access key. So that made it a lot simpler. So to retrieve the images from Unsplash, we're going to use the Ktor client. And here we configure it with CIO, although we could have used Apache or JT as well. And we install our JSON feature, we tell it, please use JSON, and that's about it. We do a little bit of extra configuration just to handle the nulls and the escaping a little bit better. To search the photos, we have to create a suspending function. Now, remember suspending, so we create a suspending function that takes in our keywords and returns us a result of inspirational images. And it's really important that this is a suspending function because it's a long-running operation. So previously, I actually went ahead and read Unsplash, the Unsplash URL, and also the access key, and we're going to use them now. So we create our URL, and we use HTTP client to initiate the GET call on that URL. And we also define a header, which I spoke about earlier, that does the auth stuff with our access key. And then we just go ahead and map the results that we get to our internal data structure. So in the beginning of my talk, I was talking about beautiful code. So let's think about what we just saw with the Ktor DSL. Is it beautiful? In the first iteration, maybe not so much, right? But in the following iterations, the framework and the language actually helped us refactor it to get rid of boilerplate and to also kind of manage complexity a bit more. It didn't require a lot of setup. And I'm not talking about the project setup, I'm talking about the code. It literally was just a small application file, and that's pretty cool. Routing was really easy to read and understand. So yes, I think that this DSL was probably quite beautiful. So Exposed is a SQL library for Kotlin. And once again, it was created in, it's open source, but it was created and maintained by JetBrains mostly. And Exposed has a DSL that you use to specify your database operations, which we're going to look at now. But it also has a DAO, or Data Access Object version that you can use. And it supports a lot of different versions, a lot of different traditional databases like Postgres and MySQL, but for the Android people in here, they also have SQLite and also H2, which is what we're going to use here. H2 is a little in-memory database. So to set up our stuff, we need to do two things. We have to first get all the dependencies into our project, and here we're saying, please place H2 exposed and Hikari CP in our project as compile time dependencies. Hikari CP is used for connection pooling. Our next step is to create our Hikari data source, the database, and set up our tables. So we have 3 tables. It's users, for the users, inspirations, which is for saving, kind of connecting the users and the inspirational images, and also tags. So this is what a table definition looks like, and it's pure Kotlin. It's a singleton object that extends table, and inside that table definition, we have different columns, and they're all represented by vowels. The first two are the most interesting. The first column is basically ID, and it's just a normal character column, but it's defined as a primary key. The second one, user ID, is also normal character column, but it references another tables column, so it's a foreign key. And we would actually go ahead and create the other two tables similarly. Now, I found a little piece of Kotlin magic in the middle of my research for this talk, and it's this. It's called the DB operation, and most database operations have to run on the right thread, and it should sometimes runs in a transaction as well. So this little function makes sure that you're actually running on the right thread for I/O, and also in its own transaction. It's really simple, but it's actually pretty effective because we use it all over the place. So this is how we would go ahead and insert a row into the table. Remember the table that we just created called inspirations? Well, it's in order to actually put a user's inspirational image into that table, we call insert on that table with a little configuration block that's going to tell us how to alter that row. The it context object refers to the row, and the this context object refers to the table. So it's maybe not so readable, especially maybe the it might be a little confusing. So to take into consideration whether it's readable, but it is quite concise. So here is also where we're going to use our little piece of Kotlin magic. We wrap the whole thing in DB transaction, which is going to take care of the threading and also the transactions for us. So here we just assign all the values to the row, and that's our database alteration code. Let's look at querying some data. Say that we want to get a specific user's inspirational images by ID. So once again, we're working with the inspirations table, and we use the select function. Here we have an interesting little piece of expression code, a little SQL-like expression that is going to refer to the column first and then the value. So inspirations.id equals ID. That reads quite nicely, don't you think? It reads like the column equals the value. It's pretty nice. And then we have a collection functions that we use to map our internal data structure and kind of pass through all the row values to it. And then we just make sure that we have just one result. What I wanted to point out next or last is this DSL beautiful? And what I really liked about this DSL is that it was pretty much following SQL very closely, which I think is a good thing if you know SQL. And I think most developers have seen a little bit of it before. So I think that is it's counting a lot. And also the use of the this and the it objects, the context objects, actually can make your code nice and concise. But considering some previous talks that we've had, I've actually kind of rethought this and thought it could be a good thing, it could also not be a good thing. You have to evaluate for yourself. But what I really liked about this DSL was the little query that we could do. And it has Exposed has a whole language that you can actually use to define your queries. And it's nice and concise and expressive, and it reads a lot like natural language. So yes, I think that it is beautiful. Our last section for the talk is really about building the front end. So I used React as a front end framework because JetBrains provides a wrapper library for React. And that was a massive time saver. So we'll also be looking at a DSL for creating HTML, which is called KotlinX.html. And finally, I'm going to show you how to use a JavaScript library and kind of wrap it around, wrap Kotlin around it so that we can use it normally. And that we're going to use to connect to our KTOR server's REST services. Just a little bit of React background. So in React, large screens are decomposed into smaller components. And this is kind of reminding, when I was attending some of the Jetpack Compose talks, it kind of reminded me of this. So our large components are broken up into medium components, which are broken up into smaller components. And the larger component, or parent, creates the smaller component, or child. So when that child component is created, we pass properties down from the parent to the child. But the events, it's maybe a button click in the child, will flow up so that the parent will actually know that there has been an event and it can handle it. So in summary, the properties flow down, but the events flow up. And this is exactly how Jetpack Compose also structured its stuff. So to actually set up the project, you go ahead and use some NPM modules, and that makes it nice and quick. So it's first necessary to install the project creator, and then you can use that project creator to create your own project. We use npm start, which will run the project in the browser and also do some live reloading. To create a component in Kotlin/React, we need to do 5 things. First, we define a properties interface. So that is the one where we pass from the parent to the child a couple of properties. We define a state interface for all the internal state of the application. We create the component finally templated with those 2 interfaces. We have to create a render method. That is compulsory. And we're going to use a nice little Kotlin-X HTML DSL for that. And lastly, we create a builder. So it's nice and quick for a parent component or another component to go ahead and use that component. So to create the properties interface, I need to extend our props. And then we pass through all the properties that we want the parent component to send through to the child. Now, unfortunately, you haven't seen the demo, but there is a photo selector component where you can select an image. So maybe we have all kinds of different pictures of cats. So we select the cat that we like the most, and that will be our little component. It will transition to the next component where we actually do the title and the tags and so on. But that is the component that we're going to be looking at. And for this component, we are going to notify the parent component when a photo has been selected. So the parent component actually needs to pass down a callback function so that the child can call it back. The state interface, we need to, in order to actually implement that one, we need to extend our state. And we list all the variables that will form internal state of that component. So in the case of photo selector, we're going to have a list of search results of just images based on the keywords that we typed in, which in this case is cats. To create the component, we extend our component, and we have our 2 interfaces that we template with it. Inside, and this is compulsory, we need to have a render method. It's a scoped function on our builder. But you can also override some lifecycle functions and create your own functions too. Now, in the render method, I created, so just a little bit of background, I used the Material Design Web Components library. And all that I really needed to do was to put some CSS and JavaScript in my project and also a bunch of HTML tags. So the reason why I did that is because I wanted it to look pretty for you. So we wanted to so the first thing that we need to do is we have an extension function on our builder called render. And the first line over here actually just creates a div with 2 classes and some text. And that forms the title of our little page. The next one will form the card. What I wanted to illustrate here is that you can actually go ahead and nest some divs, pretty much like HTML. But this is not HTML. This is definitely Kotlin, because here I'm iterating over some things. I'm iterating over those photos in order to make our cards for each photo. So to make it as easy as possible to use that photo selector object component, we actually have to create a builder for it. Now, each builder pretty much looks the same for each component. It follows a similar pattern. And here we create an extension function on our builder that you pass on all the parameters that you want to actually use as properties. So inside the method, we use our builder's child function, and we pass in what we want, the component we want to create, and also all the properties that we want to assign. And we just do the assignment of the parameters and the properties there. But maybe you're wondering, okay, this is nice, but I don't want to use React. Maybe you want to use something else. So how do we actually go about using just any old JavaScript library that isn't already wrapped for Kotlin? Let's have a look. So say that we wanted to use Axios, which is a library for connecting to just normal REST services over HTTP. And we wanted to use that one to connect to the Ktor server to get all our user data. So the first thing we need to do is use npm to install Axios. That will make sure that it's nice in the project in the node modules section. We then create some external functions and interfaces. So the important thing here is that it's marked with external and that it's going to mimic what is happening in the JavaScript. And then we pretty much use these external interfaces and functions like regular old Kotlin. So here we can see that after installation, we've got this node module in our project. And Axios is actually just a normal little function that we pass in a configuration object, and we get a promise of results back. So our first step is actually to define those interfaces. Now, here you're a little bit on your own. You have to look at either the source code or the documentation that is associated with whatever JavaScript project you're looking at. And then you have to create your little interface, your normal Kotlin interfaces that mimic their JavaScript equivalents and mark it with external. That's really, really important. Our next step is to have our Axios function. It's just a normal function. And we just give actually give the function signature and mark it external. So once again, external is really key here. We also have to link whatever is in node modules with the function. So we use the @JS module notation for that. And our last step is just to call that function actually. So it's pretty much what you would expect. It's normal Kotlin, except for one thing. And we're using a JS object to create that little piece of interface that will configure that call with the URL, the method, and the timeout. And this is part of the Kotlin JS libraries. So the rest is pretty much React specific, not all that interesting. But what's left for us to really consider about this DSL is it beautiful? It follows HTML quite closely. And there are very nice builder functions for it. But it also took the longest. It was very laborious and a little bit boring. So I would say it's kind of beautiful, but maybe not so much. It was a lot of work to actually create. So maybe. And with that, thank you. Bye, dankie. And remember to vote.
Okay, I think we are ready to start. Thanks for coming to this talk and not coming to the space one in the keynote hall. So at least a few people are interested in types, because for the next 45 minutes, that's what we will talk about. Don't be scared, this will not be a very philosophical thing. Maybe the first half of it, but you will see a lot of code, don't worry. So make it to the first half and then we'll talk about code. Now, by the end of the talk, I hope that at least some of you will be convinced to at least consider replacing some of your primitives with more types and using types much more in your code. So if there's one in the audience afterwards, I think this talk will be worth it. So I want to start with a question. Do you enjoy debugging? And maybe some of you do. I mean, here's this puzzle-solving thing, right, with it. Like, I don't know, you're like ecologists trying to understand why this code is breaking. But to be honest, in our daily work, most of us do not agree on this, and we don't enjoy debugging. I do test-driven development to avoid debugging most of the time. So imagine a world, an ideal world, where with the right programming language, buggy code is impossible to write, just because the compiler will refuse to compile and to build your buggy code. That would be amazing, right? I mean, it's a dream, but it's an ideal world. I mean, we all have been to a university, probably, and we know that no language will ever prevent us from writing a bug. I mean, Alan Turing, halting problem, things like this. But it's still nice to have this idea in mind, and maybe we can try to avoid writing those bugs and finding as many bugs as possible as early as possible. So let them find by the compiler, not by your QA, not by your customer. So, and I think the solution for this are types. And I found this quote from '78, well-typed expressions do not go wrong. And I think this is true. The problem is that very often we are not writing well-typed expressions in our daily works. So what is a type? Let's first do a definition so that we're all talking about the same thing. I found this one. A type is abstraction mechanism over data. To be honest, that's very generic. So I tried to find a better one, and I came up with this. A type is a formal description of the behavior of a program fragment. What I found interesting about this one is that it contains the word behavior. So type is more than just a few data values, right? So let's keep this in mind while we are talking about types during this talk. So to understand why types are so important, I think we should go back to a world, to a time when there were no types. So let's start at the 50s. There were a few programmers there, right? We already had program languages. But types were pretty much absent back then. We didn't have types, especially not in the way that we have them today. There's a bit of the legend that types started with Fortran, which was a very popular language in the 50s. And so actually, in the Fortran manual for 1956, you will find this sentence, 2 types of constants are permissible, fixed points and floating point. The thing is that this word type is exactly twice in this whole manual. Most of the time, they actually talk about modes. So that they say type is just a language thing, right? They didn't mean it with a specific meaning. They had 2 modes. So it was not exactly what we mean with types today. So researchers think that by 1960, with a language called Algol 60, types were born. And when we look into this, it actually says, integers are of type integer, all other numbers are type of real. And they use the word type as a specific noun. It had a meaning all of a sudden. If you never heard of Algol, it was like a language family, committee-driven. So committees would come together and define the next version of this language. And Algol 60 was from 1960. And then the whole story started. And I found this quote from a developer called Tony. You might have heard of Tony before, because there's a famous quote about $1 billion mistake that a lot of Kotlin developers know. That's the same developer. He also invented things like quicksort. So he has quite some history. And he said, like in the 60s, you know, the result of any program should be comprehensible without knowing anything about the machine or its storage layout. And he thought that types are the goal for this. So types are not only for memory requirements. So an integer needs a certain amount of bytes. But if you have 2 programs, the same program running on 2 different machines, they should give you the same result. And we didn't have this in the 60s or the 50s. So he said type is the solution to this. We have to abstract this. And his suggestion came into a language called Algol W. You might wonder why this doesn't have a year. Algol W, although it was influencing a lot of languages afterwards, never became official standard, unfortunately. But all these developers work in Algol, they worked on languages you have heard. So let's keep going and go to the 70s. And types, there was one thing missing when it came to types to compare to what we have now. And I found this article from 1973 from James Morris, another famous computer scientist. And he said, you know, the type system should guarantee that only specific operations on a type should be possible. So an integer type, only the integer operations should be allowed there, right? That was like this, there. But for all the user-defined types, it wasn't like this. And today, we create a class and adding a method, and we can only call these methods, right? For us, that's totally normal. But it wasn't like this before. So he suggested we need to fix this. And it was fixed in a language called Pascal, which is a direct, it was done by those people who did Algol W. And Pascal had a lot of variations of create custom types. And researchers basically say that with Pascal, types became the central feature as we know it today. And this was the 70s. We could basically directly jump to 2010 when Kotlin was born, right? Maybe we should have a quick look what's happened since then. Just like a brief overview through the decades with types in mind. So the 80s, the dawn of object orientation, right? Starting with Smalltalk, C++, Objective-C, that's OO, kind of as we still do it. So the type structure we use for abstracting, for modeling, all of a sudden. And a type was basically a class, which how we mostly still perceive it today. The 90s, like the age of internet languages like Java. We heard just a lot about how Java evolves from Jake. It all started in the 90s, as he also showed. And then his little ugly brother, J#, which later becomes C# and all of those. There's a problem that Java still tries to fix, and Kotlin fixed for us. A lot of the boilerplate we had to write of Java, and I found this nice quote. You know, object-oriented languages made static typing so painful that many of us just gave up on it. And this kind of defined the next decade, because dynamic type languages appeared. JavaScript, Ruby. So we kind of gave up on static typing, right? That doesn't mean there are no types. They're called dynamically typed languages. So they're not typeless. It's just a difference when we enforce the types. All the types are still there. That's why the Ruby developers like to do TDD, because they can check the types in the tests at least. But still, I played with Ruby a while ago. It was nice, but I don't know, it wasn't the original idea of like all these researchers who tried to give us the compile time safety, right? So, but they're there and stayed for a while. But then something happened in Java. Jake just mentioned as well. Generics happened. And I found this nice quote by Bill, who was working on the generics. You know, after you ship, fixing a bug costs like 10,000 times as much as catching it in the first place. And generic tries to push this boundary a bit to the compile time by giving us more safety there. And like imagine like the time, as Jake said, without generics in the language. It became a central feature for us. Last decade, functional programming came back. It was there before OO. And all of a sudden, functional languages like Scala appeared and became really popular. And maybe some of you might think, it's functional, there's no type, we are passing lambdas and functions around, right? So we gave up on type system again. Actually not. Functional programming languages are traditionally typed. And actually, types play a very, very important role in functional languages. So think about your mapping from one type to the other. Think about all these new types those languages brought us, like either. Like there's a standard outside from arrow. There's a ton of new types. So functional languages use types a lot. They're basically built on top of it. Immutability, the core principle of functional programming. That is how we do OO nowadays, right? So don't think functional programming has nothing to do with types. Types play a very important role. So let's keep going. Yeah, the developers for JavaScript thought, did we do the right thing? So I found this quote by Anders Heisberg. You know, you can write large programs in JavaScript. You just can't maintain them. And actually, Anders, from what I heard, is a big fan of JavaScript. He has some history, so he did TypeScript. He created C#. He created Delphi. He He was the guy behind Turbo Pascal. So he has some background of language, so maybe we can trust him. So we kind of realized, okay, maybe JavaScript wasn't the best idea, but we can try to fix it with TypeScript. So types came back, so even at that part, right? Which I found very interesting. And then this endless fight with typed and untyped. A lot of researchers and developers thought us, maybe we're asking the wrong question here. Isn't it more like if we need to explicitly write the type, right? So fix the problem that Java and Co introduced in the first place. And we brought something back called type reconstruction, which you might have heard as type inference. It's the same thing. And type inference is an old concept, and Kotlin made it as its core. So we reached Kotlin by now. Java has now var, you know, since Java 10. So type inference was a principle that has been there, was basically discussed in all these decades. So it's not an old, new principle. But finally, we put it in language and kind of brought all these specs together. When you think about Kotlin, a multi-paradigm language, a little bit of functional, it's OO, it's statically typed, but type inference, so hopefully this is the future. So Kotlin has basically types in its DNA, right? Think about nullability, like null safety into the type system. First-class functions, think about nothing, like a type that represents the absence of anything. So it's just there so the compiler can check if this method returns. It's very interesting. So Kotlin tries to use the compiler as much as possible. So if Kotlin can do it, so can we. So we love Kotlin, but we still don't use the power of types. And this is basically because of this. Now let's talk about us, all of us here. We're all guilty of this. We are obsessed by primitives. This is not a term I came up with. This is an official anti-pattern. It's called primitive obsession. What does it mean? It means the usage of primitives instead of small objects for simple tasks. A user is not a string, but we all write it like this. A phone number is not a string. It's a phone number, but we always model it as a string. It also means using constants for coding information in there. Admin role equals 1. We are writing this kind of code. Think about it. We are writing it probably every day. This is primitive obsession. Probably all of us are guilty of this. So let's look at an example. You've probably written code like this. I have a value of time. It's a long on int. And then someone reviews the code, said, what do you mean time? What kind of time? What's the unit here, right? And then you fix it. It's time milliseconds. Said, yeah, you know, wouldn't it be better to not put it into the name? Yeah, sure, I can fix it like this. So it looks better, right? The readability is solved. It is still as unsecure as it was before. You can pass anything there. You don't have to check the type. Okay, let's try to fix it again. How about making a data class and putting the time there? But now the millisecond thing is back. So we put it in the class called time, which is nice, but we still don't know the unit, only in the name. And come on, naming is hard. Don't put a type there. So we can do it like this. Let's separate those two. There's a value and there's a unit. If you don't know time unit, it's there in Java for a long time. You can use it in Kotlin. So now we have a class that separates value and the unit. And looks maybe hard to use, but actually you can write extension functions like this. And then an extension function on integer or long that creates you this time value. So use the power of Kotlin. And then go on, use the power of Kotlin for operator overloading. All of a sudden you can have a time value in minutes and in seconds and subtract them from each other because it's a type. And you make it absolute safe. So first rule, don't put in a name what can be in a type. If you want to remember one thing from this talk, try to remember this. Don't put in a name what can be in a type. And when we think about this, as you realize I like to talk about history, when I started developing, we did this a lot. We put the information about the type in the names. We put in if this is a member, if it's a string. I even had like a company, if it's like an input and output param, it would all be in the name. It was called the Hungarian notation. And this is what Linus Torvalds thinks about it. Encoding a type into the name is brain damaged. And hopefully none of us has to do Hungarian notation nowadays. We gave up on it during the last decade. But although we gave up on the M underline thing, we still put a type into the name, like with the time milliseconds, right? We do it all the time. So maybe remember Linus Torvalds' quote here, and don't do it. So let's keep looking at our example. we had a method like this. So my last company, we had like a video software, and you could cut a clip, and you would have a start time and a duration. And there was a suspend function, because of course it takes the time to create a video. And then I would call it like this, right? Cut clip, 5 seconds, 30 seconds long. Looks nice with the extension functions, right? But when I remove this, what does this mean? Is this a clip 5 seconds to 30 seconds? Or is this 5 seconds to 35 seconds? So is it start and end, or start and duration? I cannot tell by reading this method. So it means I can abuse this method. But to be honest, a good API should be impossible to abuse. Well-typed expressions do not go wrong. Remember this. Let's fix it. How about this? So we create classes for this. Point in time and time delta both contain the same information. They have the same time object, but they are different things. So let's express them as different things. One is a point in time, and one is a delta. And then actually what we can do is, hey, we can have both versions of this. This wasn't possible before. So you cannot abuse this, and whatever you want to do with the cut clip, you can use it right now. And now you probably see, come on, this is overkill. Actually, Kotlin time has a class called duration. It's in Java 1.3, still experimental, but it's there. Duration, they don't have a type here, but this is just because you use extension functions to create this thing. So if you thought that my milliseconds extension function int was a bad idea, JetBrains does not agree. They have, on all the numeric types, things up to weeks that you can call. And duration basically encapsulates. So this is how you create them, and internally they know that this is milliseconds or something. So instead of time delta, we can use duration now. And I hear this actually a lot about extension functions. So you're polluting the namespace of my integers or my string. This is just a problem because you're not abstracting them, because you're using the primitives directly, because you're obsessed with the primitives. If you hide them, you hardly ever see this. So it seems like JetBrains at least agrees with this one. This is cool. So let's show you another example. Recently, I was refactoring. So we have some subscriptions at SoundCloud. I was refactoring the screen, and there was like some formatter, and it gave me like a price info and one on the discount price, just like a nice formatted string. And I made a mistake, and happily we had a lot of unit tests, so I catched this. But then I thought, wait, we have two prices here. And the only difference is the method name and the variable name. But why could I even make this mistake in the first place? Why could I pass in the discounted price into the regular price, or the other way around? It seems like we have two different things because we have put in a name what could be in a type. It seems our domain has a regular price and a discount price. Our domain says these are two different things. This is domain-driven design. Thank your domain rules and put them actually in your code. And don't put them in a name or in a document somewhere lying around no one ever reads. And as you can see, now both the methods can be called price info. We can just overload them. This reads so much nicer. So this is domain-driven design, very expressive. Try to use it. I'll show you another example. At SoundCloud, we identify most things like tracks and users and playlists with a thing called a URN. It looks like this. It's a string. There's some namespace, there's like identifier, like is it track or user, and some ID. And then we have a class to encapsulate this, because not primitive abstraction, right? And it looked like this, data class. And then you ask, hey, is this a track, is this a playlist, and so on. And I was looking at this, and I thought, it reminds me of this quote from Scott Meyer's Effective C++, a book from the 90s, one of the best written IT books. So anytime you find yourself writing code, if object is of type T, do something, otherwise do something else, slap yourself. Why? Because you have not understood object-oriented programming. You're doing something wrong whenever you do this. I used to have a post-it, like when I started programming on my computer, to know when I need to slap myself. So when I saw these type properties, I thought this is kind of the same thing, right? We had a method that tells me what type this is. So if you see something like this is a smell. There's, I think, probably a hierarchy here that we should use. And then I keep going, and then I saw is user and is valid user. So, and then in the code, we would usually first check if it's a user, and then also check if it's a valid user. So every time you use this, you have to do both. And it's easy to forget. Someone else like me comes into the team, right? And I didn't know that I have to check is valid user. So these are kind of dependent properties, but they're on the same level. I think there is a hidden type here. And then I saw like how we create those, and there's like a for user, a for command, so like factory methods, but they all return the same thing, right? Might be a smell if you see the factory method that return the same type. Doesn't have to be, but I think there are hidden types here. Let's try to fix it. So what we did is like, we have a sealed class, and there is a user URN. And only the user URN needs to check for is valid user. Actually, we need only is valid because we know already it's a user. So this looks so much better, and we actually extracted the types. And then when you use it, we had something like this. We had a command, and the command itself is identifiable with URN. And then there's a track that you're commenting on, so track URN. And there's a user that writes this command, so there's a user URN. And so 3 URNs, that's very easy to pass the wrong one. Also, like, look, one is called track URN, one is called commenter, so there's no alignment here. With types, we can simply fix this, right? Take the type out of the name. There's a comment URN, there's a track URN, there's a user URN. This is easy now. You cannot pass the wrong one. And actually, when you keep going, and this will happen when you go to domain-driven design, comment is reply. Clean code will tell you if you ever pass a Boolean into a function, you're doing something wrong. Because this function, by definition, will do 2 things. But the method is only allowed to do 1 thing. If you pass a Boolean into a constructor, it's at least a smell. Because probably there's a hidden type here. There's a comment and a reply, which is a special kind of comment, right? So we could abstract here. We left it. But there's something else. You keep seeing these things when you start using more types. So I was then looking into this is valid of the user URN, right? I just showed you. This was the implementation. It was basically checking if the ID of this user is not empty. So there's a user, but if the ID is empty, it's not valid, which makes sense. But my question was, why could I even create this, right? So I would call it don't let it creep in. There is a developer called Ivan Mogilov in Berlin. He talks about domain-driven design a lot. And here's a sample of a passport. When you go to the office and need a new passport, you give them all your documents, all your information, and you either get a passport or you're not getting a passport. You're not getting a passport where the name is missing or where half the pages are missing. And every time you use this passport, you have to check, is this the one with the name? No. But OO is for modeling the real world. Why are we modeling the world like this? It's not existing like this. So don't let it creep in. So try to fix the things in the first place. So we could do something like this, right? We can have a check it on the constructor. If it's empty, throw an exception. The problem is we are moving it to the runtime. The whole thing, my talk is about doing it compile time. So also you need to know in Kotlin, we don't have checked exception, that the constructor might throw an exception. So might be not the best thing, especially when you think about the error handling code you have to write here. So what we use a lot, developers, I mean, is something like this, right? You have like a method, create me a user. And it either gives you a user or null. Normal pattern. And then we can make the constructor private so that no one else uses it. So you have to go through those build a factory methods, however you want to call them, right? That's nice, but can we make this better? Sometimes I saw something like this, that you call the function like the class. You have to then put them in 2 separate packages, otherwise it will not work. You can't make it private, unfortunately, so you need to be internal, so you need a separate module. It kind of gets dirty here, but if you look at the usage, it looks nice. You're creating a user URN, right? But you're getting either null or user URN, which is kind of cool, but I don't like the different package thing and like that the constructor is not private. You can easily cheat this, but we're getting there. So let's go back to the original version with the for user. What else can we do? We can put it into the companion object, put it close to the object instead of having it outside. And then this is something that they do a lot in the domain-driven world, and call the method off. And then you use like user URN.off. So it's a method that either returns you a user or null. This looks nice. In functional world, they often call these smart constructors because they're more like they're like constructors, but not really, right? I think with Kotlin we can make this even better. What do you think about this? We can then invoke operator in a companion object, and then again this looks like a constructor. So because I call user URN not invoke, this looks really nice, but it's a constructor that is basically nullable. And now you can even go crazy. Maybe you have to have an email address that needs to be validated on server side, because you have to really check if this user is allowed. How about making the suspend? We can have a coroutine-aware constructor. I don't say you do this, but all of a sudden you have these possibilities. So this is like the nice thing of Kotlin, right? We can do all these nice things. So smart constructors. But you think, yeah, Danny, that's like a really good idea, and I know we should get it, but the costs, this will be so expensive. Like allocation, memory, garbage collection. I mean, come on, who thinks here this is very expensive, doing like type everything? I have the wrong audience, that's cool. So I hear this, at least I heard this a lot. So let's talk about costs here. So what does it actually cost doing this and type all these things? So I would separate into the two things I just mentioned. Allocation, the memory that we need, and the garbage collection runs, and the cost of the garbage collection that we need. So we will focus on JVM, because this is my the area of expertise I can talk about. So JVM and Android. So allocations. You know, on a JVM, all the allocations happen in a thing called Eden space. It's like one big memory, and as you have multiple threads allocating things, you don't want a thread synchronization. So it's basically split into a thing called thread local allocation buffers. So it's basically partitioned into small pieces of memory. The nice thing is there's no synchronization. Each thread has its own thread local allocation buffer. That means that allocating something is an increase of a pointer. That's basically it. There are actually some numbers. I can show you a link later where, I think from Oracle directly they came. So allocating something in a JVM, it's like 10 machine instructions. Doing the same thing in C, like a malloc, is between 60 and 100 on the best case. So you're 10 times faster, up to 10 times faster, because all you do is like allocating pointer. Of course, the buffer might be not large enough, but we're talking about very small objects here. So it's just allocating the allocating pointers. So there is no cost here. And actually, compilers are smart. The compiler might even inline your whole class without even making it inline. There's a thing called escape analysis. So the compiler will see, where's this class used? Does it even leave this method scope? If not, it will just remove this class. This is a very clever thing. Allocation, elimination. Again, trust your compiler. So allocations on a JVM are very cheap. But let's talk about Android. Android's always a different world, right? So on Dalvik, maybe there were like moves about don't allocate too many things, right? Like in the early days of Android. It is different. Art is optimized for allocations. And actually, last year's Google I/O, that's Chet Haas was saying basically this. Allocations are okay now. Types are okay. Yes, even enums are okay. So the ones who are laughing here are probably Android developer. They know that we had this thing, please use an int and not an enum. It's not a thing anymore. Chet said it, so you can watch that video. So types are okay, you can use them. So, okay, if allocations are cheap, we still have memory, right? So all these wrapper objects and wrapper of wrapper of wrapper, they will sum up. So let's look at this. So we have to pick like Windows and a very early Java, just to have some number that we can start working on. So plain objects back then had 8 bytes of memory. So I think we all can agree on that any wrapper around something will be 8 bytes larger than without. I guess that makes sense. But careful with assumptions on memory. An empty string is 40 bytes. Don't ask me on this machine. A Boolean, which is 1 bit of information, on a newer JVM, takes 2 12 bytes, the 1 for the information, plus 3 for granularity. There's actually optimization happening via the compiler on your machine. So sometimes it's quicker for the machine to read memory in certain blocks. So even if you have 2 bytes of information, it might read them in 8 or 16 byte blocks. So they might be padded. So don't make assumptions. This is actually what documentation said. The size of type is not defined. Don't trust this. So let's look at Kotlin. If you have something like this, like an age that is an int, the Kotlin compiler is clever. He will make this the primitive int into the bytecode. You can see this. So this is nice, right? Not much memory. But then you make it nullable because you have this special case, right? Now the Kotlin compiler cannot do this anymore, and although you just added 1 character, it will be much larger because you have a Java long integer. You have the boxed version of it. So let's look at my version. I would put it in an H, put the integer in there, and make this thing nullable. So now the Kotlin compiler can use the int in there. So I have an int and the cost of the wrapper. So this is already very close, probably, in cost of memory. We can make it inline. With this thing, the whole this whole method, the whole class, will be translated to an int. If you make it nullable, Kotlin will keep the H class, the Kotlin compiler, and the int will be an int. So the costs are not as high as you might think they are. So the last thing is garbage collection. So we talked about allocations, we talked about memory, so don't make assumptions on memory. But garbage collecting, come on. You're creating all these objects. You know, the performance of the garbage collector is not determined by the number of dead objects that you might think it is. It is actually determined only by the number of alive ones. The reason behind this is that we have, and this is the same on Android, we have generational garbage collections. So they have like an old and a new generation. And everything that happens in a new generation is very fast. So what takes time is finding all these alive objects and see if they have to move to the old generation. So short-lived objects are very cheap, even when it comes to garbage collection. And it makes sense, right? We talk about allocations. It's just like, okay, let's free this memory, decrease the pointer to make it very, very simple. So what I want to tell you, types improve your readability. Types give you documentation without you having to write Java doc. Put the information into the type. Type helps you with the compile time correctness. You get like a machine check documentation of the whole thing. As I said, let's try to avoid the bugs in the first place. And type actually improve abstraction. Not only because we're doing OO and we're modeling things. Think about you have to modularize your project. And then you have to think of where this price thing is used, like the discounted price. Find all the places and you want to have a discount module. It's impossible to find. You have to do a string search on your project. If this would be a type, all you have to do is check the usage of this type class. And then you see the things that belong together, and by Uncle Bob and the solid principles, if they change together for the same reason, put them together. So put them probably in one module. So type actually helps you modularizing a project. Think about this. I think this is a very cool thing. So the message here is that types are actually enablers. Types enable a lot of things. So start watching out for these hidden types. All the type information that we put into the names. Look out for these is type attribute, right? I mean, there's always a reason why we did this. There's a reason why the URN, the user URN looks like this. It was Java. We had like a mixed code base. And for Java, there came non-nullable things in there and things like this. So, but if you find it, come on, do the Boy Scout rule. Let's start with a factor and come up with something new. You don't have to start with a new project. Booleans, if you pass Booleans into a constructor, think maybe, is this a hidden type? Do I just make it quick? And of course, look out for all the primitives that we write every single day. So let me end with Tony. Tony said, 1960, or 1966, you know, my goal was to ensure that all use of the references should be absolutely safe, with checking performed automatically by the compiler. He had this goal back then, 1966. But I could not resist the temptation to put in a null reference simply because it was so easy to implement. And we have this every day, right? That I know the right way, but you know, I want to go home. I want to push this out. He called it his billion-dollar mistake. He created the null pointer that we have until today. Kotlin saved us from this. But 1966, probably in that moment, he didn't thought it has such an impact. So please let the compiler do the work for you. Type all the things. And I have a lot of sources, so I'll put these slides online. There's a lot of reads, amazing reads of like old papers and like researchers trying to understand how we came up with the type system. There's a lot of interesting blogs about how to best avoid primitives. Really nice one, let me recommend the one from Mark Seeman about domain modeling. He's really big in the C# community in F#. I just wrote last weekend, someone, after I did the first version of this talk at the meetup, said, you know, in Scala we have this thing called phantom types, and use this in builders a lot. So I read this article, and it was really cool, and I thought, can you make it in Kotlin? So this is my first version of it, but the Scala article is very long. So have a look. There are like interesting ideas there. And then, of course, if you don't believe the cost thing, there are a lot of sources for this too. So I thank you. Please remember to vote. I think I'll leave you a bit early. So come here, ask me a question afterwards. Thanks.
Hello, everyone. I think we can get it going. I still see that people are coming through the doors. So let me first introduce myself. My name is Fedor Korotkov. Unfortunately, Victor didn't make it to the conference. He and his lovely wife just had a new baby, so he stayed home. So cheers, Victor, if you are watching live or in recording. And in the meantime, while some people are still coming, I'd like to first ask the audience, how many of you have edited a YAML file in the last month? Can you raise a hand? Okay, awesome. That's for the record, for those who are watching, it's probably like 95, 99%, almost everyone. Okay, awesome. And what about, are you using Kubernetes at work right now? And what about people that are planning to use Kubernetes in 2020? Okay, so I'd say pretty much like 80, 85% people using it right now, and almost basically in the end of the next year, everyone will be using it. Okay, awesome. So I think everyone, like, doors are closed, so we can start. First of all, I want to set the expectations for the talk. It's not rocket science. We'll literally take a look at only 3 features of Kotlin in order to achieve a very flexible DSL for interacting with Kubernetes, and then I hope you will enjoy the demo in the very end. But first, I will start with some meme reviews, because I know it's second to the last talk on the last day of the conference, so just let me try to cheer you up. And since everyone knows what YAML is, and you have edited it in the last month, you know that YAML is indentation sensitive. So you actually need to keep an eye on your indentation and make sure that everything that you're writing in YAML is aligned. And what is the best way of making sure that everything is aligned? Is just like adding a ruler to your monitor. But this is a really good life hack, actually. I mean, I would imagine that some people will use it. And just a matter of fact, there is now a special position, which is like senior YAML engineer. I know the title is a little bit fun, but this is an actual position open. And as you can see, it's all about doing infrastructure for AWS. And yeah, you will need to edit a lot of YAML files. And the description of this position also involves a little bit of Go for some tooling around the infrastructure. But yeah, you will probably full-time do YAML. And finally, I know that we're going to talk about infrastructure as code a little bit later down the talk, but I want to just give you a small preview of what these kind of YAML files can look like for infrastructure. As you can see, it doesn't look like YAML very much, because you can see there is some templating engine involved to do the injection, as well as you can even have imperative if statement in your declarative by nature YAML. And also you have bash injection. So on this small example, this is real example from Kafka Helm chart. You can see that you basically have kind of 3 languages, 2 languages and templating. So when I see something like this, I'm speechless, like right now. But then I always remember in this kind of picture, because this is literally something weird happening. Okay. Hopefully you like the memes, and it's sometimes better to look at the problem through jokes first, because then it's much easier to admit the issue and finally start working on it. So, but now let's start to be a little bit more serious. Let's first of all learn how YAML came around, because for me, I always knew YAML. I used it for small things, and then this like boom of infrastructure as code came around, and now YAML files are not like they used to be. So YAML initially was released in 2001. It was called initially yet another markup language, but it was like quickly repurposed into YAML ain't markup language. So you can see there was a like confusion from the very beginning. And from the wiki, it's like YAML is commonly used for configuration files. But basically, you just want to declare stuff. And as we saw in the preview of some YAML files that are popular right now for infrastructure, it's not declaration anymore. It's like, you actually try to do like if statements, for loops, and so on and so forth. So it's not like it was intended to be. And unfortunately, YAML is not going anywhere because it's actually pretty good when it's like small examples for like presentation. It's pretty easy for human eye to understand when it's small, when you don't need this like ruler. So if it's like a few dozen lines, it's actually pretty nice. But there are some real problems because as you also all know, YAML is not only indentation sensitive, it also doesn't have built-in mechanism for custom types. So you only have primitives like numbers, strings, lists, and objects. And therefore, you need to somehow parse it and either deserialize or translate into internal representation of your model that you use. And sometimes people make mistakes. And like in this case, for example, a version was parsed as a number instead of a string and was used actually in a string. But since it was a number, it was rounded down. So instead of 110, you got 1.1. So you, instead of upgrading one version, like bumping one version, you also actually like downgraded 8 versions, which is not nice. It's good if your like tests would have find it. And just a sneak peek. Anyways, so there are tools around it, right? So there are like linters that you can have to validate your YAML files to make sure that everything is according to the documentation, to the objects that you are expecting. And probably you can also relate to this experience when you have like 2 windows. One, you're editing the YAML file, and the other is documentation, and you're just like moving back and forth because you don't have completion. You need always to check what's going on, what kind of fields there are. And but the problem here is that it's not out of the box. You need to configure something, and all the linters, these tools are not particularly good at recovering from errors when you have almost valid input. For example, you probably all use in JetBrains IDEs. You know how good they are at doing completion when even your code is not fully like compilable when there are errors, because JetBrains, they tend to care about how the custom parsers, they recover from such errors. So yeah, you can, with these tools, you can easily get into a position where you have like one mistake, but then like parsers breaks and there are like just too many errors. And this is like a real case that like happened to me. And finally, I need to mention that there is actually a schema for YAML files. It's called JSON schema. So why is it JSON? Because from YAML specification 1.2, it was actually started to be compatible with JSON. So any valid JSON can be easily translated into a valid YAML. And you probably may notice that JetBrains IDEs actually started supporting this schema, even though there is no final draft for the JSON schemas. And in your IDE, you can see in the bottom right corner that now your IDE can detect the schema and then provide your completion and validation, which is nice because it's, again, you want something that works out of the box, so you don't need to configure this, and it works pretty nicely. Okay, so I want to first admit that YAML is great, as I mentioned, but for small things. And we will talk a little bit right now about the infrastructure and Kubernetes as well, of course, before jumping into the Kotlin side of the talk. So, as I mentioned, this infrastructure and YAML files for infrastructure, they're not feasible for humans anymore. They're literally screens and screens of different configurations. When you have YAML, you have some templating and of course bash scripts. So this tweet pretty much describes the issue, because just remember how, if you can remember, how working and how creating applications, how development process was different in 2001. There were not so many abstraction layers like right now. You had Word was simpler. Right now it's impossible to catch up with everything that's going on. And with more abstraction layers, you are getting more and more, not only your application is growing, but also how you do the infrastructure and all the tools around it are also getting more and more complex. So let's see an evolution of YAML in a company. So probably when you just start something doing, you have one server or something like this, you can pretty much do everything with scripts. You don't need YAML, you can do some deployments, you can copy some jars, or Docker can start Docker locally on the machine, and you don't need anything when you have just a few of servers to maintain. Then, when your fleet is growing, you start using something like Ansible to do the configuration of your machines. And then finally, when you do get fancy and start using Kubernetes, you end up with Helm chart. You use some Helm charts, you write some Helm charts, and I think that the next step in this evolution can be actually Kotlin DSL. So I know it seems like everyone pretty much knows about Kubernetes, so I won't spend a lot of time talking about it. I just want to stress one thing about Kubernetes. So Kubernetes is a container orchestration framework for deploying your applications. And the interesting and the most important part for this talk is that Kubernetes API is actually declarative. So what does it mean? So in the world of Kubernetes, you don't specify how you want to deploy things. You specify that you want a deployment. You just create a deployment, and Kubernetes makes it happen. So for example, you create a deployment for your application with let's say 5 replicas. You want 5 containers, so you just create it, and Kubernetes sees that new declaration of a deployment. It understands that it needs to find resources for 5 new containers. It finds available resources, starts them, makes health checks. If you also created, for example, a service object, then it will put DNS records and so on and so forth. But we need to also mention that the API that Kubernetes is using is actually JSON-based. So in your pipeline from your infrastructure as code to actual infrastructure running, there are so many steps now. You have YAML with some templating that gets translated into a huge YAML. Then this huge YAML is translated into JSON. And this JSON is finally submitted to Kubernetes, which can make validation for if it's correct or not. So pretty complex stuff. And if you Google for Kubernetes YAML, you're getting almost 2 million results. So it's I think infrastructure as code, and particularly also Kubernetes, is the most growing area where YAML is using right now. And like the usage there is, I think that the problems we're trying to solve, they outgrew the capabilities that YAML is providing to us. But again, I mentioned that YAML is great when it's small, but what should we think about when we have, we're scaling our like infrastructure, when we have several teams, each team has like several configurations that they maintain. So we think about how to avoid copy pasting of your YAML configs. That's why you probably use like templating. You try to provide primitives, and you try to provide customization for the team so they can tweak settings as they are required for their needs. And also how to test these incremental changes. And if you just look at these statements, it's basically just same as what you're doing when you're coding in Kotlin, for example, right? You also want to avoid copy pasting by having like common libraries. You want to use third-party libraries. You want these libraries to be very flexible, so you can customize behavior and so on and so forth. So this is probably why it's like called infrastructure as code, and you actually want to code something, but then you end up with the YAML. So here's a small example of how a simple YAML config looks for Kubernetes. So this is an ingress example. Ingress is a way to expose your internal services from Kubernetes to outside world. So that's pretty nice, right? As I mentioned, like YAML is great for small things. When it fits on a slide, it's great, you can see it. But probably by that time you can proxy it to the issues when it's like hundreds of lines. And will it be nicer if the experience, instead of that, you will do something like this using Kotlin? So as you can see, out of the box, you will get completion and type validation and just, in general, experience that you are used to while programming, instead of like switching between browser and your editor because there is like no completion, and you don't need to configure anything extra. And as you can see, there's like special types like int or string, because it like can be either can be like name or an actual port number. So, so how does it work? This Kotlin DSL library is actually super simple. So there is already a Java Fabricate library that provides you with a client that can talk to Kubernetes and model objects of the Kubernetes API, the standard one, like deployment, like stateful set, like persistent volume, and so on and so forth. So what this project does, it does two things. First, it has a generated DSL for the standard types that you just saw, the ingress one. And then it's also possible to, with that Kubernetes Kotlin DSL project, to generate these fabricate types from a CRD. So CRD, it stands for Custom Resource Definition. So in Kubernetes, you have objects that you create, and there are standard ones, as I mentioned, deployments, stateful set. But some companies, they do create their own abstractions that you can deploy to Kubernetes. For example, Confluent, a company that Victor is working for, they have their own Kafka operator. So they bring the same experience to Kubernetes. So you have Kubernetes now knows that there is a thing called Kafka, and you don't need to manage yourself like stateful sets. You don't need to manage like persistent volumes and scaling, all of that. The operator takes care of it. You just create a Kafka object, and you just specify how many replicas do you want. So let's see those 3 language features that I mentioned that is used in the library itself. So the library itself is just a bunch of generated functions. One kind of these functions is builders that help you to build these new objects. And in order to build it, it's like simply uses higher order functions with functions with the receivers, which allows you to instantiate a new object and then just apply the modification that you passed along the way. And for also, excuse me, that it's not the pretty Kotlin, it's generated Kotlin, so it shouldn't be pretty. It specifically generated this way because even though names of the objects that Kubernetes are using are unique, fields of those objects are not. So to avoid collisions, the generated code is not that pretty, but you'll get a nice experience in the IDE afterwards. So, and the second thing is how you do, and the second kind of functions is are the extension functions to do modification of these objects that got created. And this is pretty much the same. It's a higher order function with the receiver, but now it's an extension. And you can see that it simply checks that if a field is initialized or not, and then applies the modification. As I mentioned, no rocket science, it's super simple. But now let's see how this thing can be applicable in your deployment. So now we'll do demo. So how much time do we have? Oh, we have plenty of time. So I've already created a Kubernetes cluster, which does have this confident operator deployed. So you can see that now Kubernetes knows about Kafka clusters. So you can get it, and you can also see schema of it. So as you can see, it defines the schema, it defines what kind of properties there are, and so on and so forth. And this output can be used by the Kubernetes Kotlin DSL project to generate these fabricate types, and therefore, after that, generate the DSL as well. So it's a good time to mention that the CRDs, like operators that are created, they can be written in any language. This one, for example, I think is written in Kotlin or Java, at least. But most of them are in Go. And by just generating the necessary custom DSLs from the API response from the schema, it makes it much easier. So you don't need to like parse, I don't know, like Go or try to do some like type inference from Kotlin. Okay, so you can see I have this Kubernetes cluster on Google Cloud, and you can see in workloads, hopefully it will load. Yes, in the workload we have the Kafka, so like this CRD, the operator that handles everything, and there is also another CRD for Zookeeper and for this manager. So now let's switch to the IntelliJ and see some use cases that we can achieve by using the Kotlin DSL, and how we can avoid copy-pasting, how we can make some extensibility, and so on and so forth. So here it's an example. This file is an example of how application configuration file is created. So we can create a secret for our, like Kubernetes secret for our deployments to use. And here in this file, I want to highlight one particular thing, that here we're checking if a Kubernetes cluster that we're trying to deploy to, if it already has a Kafka, because you can either have a Kafka that you run your own, or you can use some cloud solution that the Confluent, as a company, they also provide. So here we check if there is already Kafka, then we will grab the specification how to connect to this existing Kafka, or otherwise we will check that application, the properties file that was provided actually contains necessary information that we need. So, and right now, if you think how you can do the same with the regular Helm charts, I'm not sure how you can do this, because you probably will wrap your already existing Helm chart in some other script, so it doesn't sound pleasant. So let's try to create this new configuration file that our application will use. Again, this secret contains configuration how to do like port numbers, the Kafka address. So let's create the application config. Okay. Yeah, you have a machine with 8 cores and it doesn't work that fast. Okay, awesome. So we now created the config. We can go through the UI and see that we actually have the config. Here is it, application config. Now let's see how we can deploy things. So let's go to the Clift deployment. Okay, where is it? This one. So we will see what this application look like. It's like an Uber, like a Lyft. Lyft is also very popular ride-sharing application back in the US. So as you can see from our deployment example, we already have an abstraction here. We have a base deployment. So if we go into the base deployment, we see that we can start creating special abstractions that we can reuse. And we can, for example, if you have an infrastructure team, this infrastructure team can create them. For example, they can create a common abstraction for connecting login aggregation to your service, or some metrics aggregation, or how to connect to a database, and so on and so forth. For example, we internally at Cirrus have a similar base deployment, but you can also provide things like defaults, like how many resources a service requires. Is it more CPU intense, or is it more memory intense? For example, how many replicas by default it needs, how aggressive autoscaling should be. And it's all coming through constructor arguments, and each microservice can define their own and also do an easy modification. We will see back how Clift deployment makes the modifications. But right now you can see that we only provide the service name that we want to deploy and some default amount of replicas, which is by default is 1. But you can see that this is pretty much, we can extract it. And since it's Kotlin and it's an IntelliJ, we can actually do refactorings. And we can extract this. And then to this scope, and IntelliJ will find the overrides. And then we can extract it and call it common labels. No, there was a typo anyways. But you get the point. It's like much nicer experience to edit infrastructure that way rather than YAML. So, okay, so now let's go back to the Cliff deployment that we have. So we use the base deployment to get the base deployment configured with all the necessary labels and replicas. Then we can override what kind of containers do we want, and we can also get the config from the secret that we already created on the previous step. And now let's do the deployment and finally see the demo. Okay. So let's now deploy. Hopefully this time it will be faster. Yeah, wonderful. So now it's deploying, and if we'll go to the workflows, let's use UI for more for visualization. So here we have the Cliff deployment that we just added. Since we defined only one replica, we have one pod going. So let's go back here and do port forwarding. I don't have the ingress for the matter of this presentation, but we could have done it. And okay, what's wrong with it? Okay, got it. Okay, port forward. Now it should be running. Let's switch here. Okay, so it's a ride-sharing application that uses Kafka in order to stream position of both rider and driver in real time. So here on the left-hand side, we have the rider application that like this rider is waiting outside of the Bella Center. Then on the right-hand side, we can put ourselves somewhere. Let's put us maybe here. And then, oh, it's probably, there are two people now. It's probably because I ran the demo beforehand and I put it there. Let's, for the sake of the demo gods. Oh, crap. Okay. Okay, once again, I ran it multiple times. Okay, let's put ourselves somewhere here, and then we choose this person instead of the other one. So you can see it's like in real time start driving. We don't see our ghosts from the previous ride, but we see the ghost car. Anyways, again, I'm not front-end engineer, so I'm not sure what's going on there. But you get the point. It's a pretty nice application. And while the ride is going on, we can explore some other use cases. So as I mentioned before, when you do infrastructure, unfortunately, you not only need to declare this, like how you deploy application and how your infrastructure is looking like, but sometimes you need to also write some scripts to understand what's going on in your cluster. Just imagine if you like have a big company, you adopting DevOps, and then every team like has freedom to deploy whatever they want, like almost whatever they want, using the primitives like this base deployment that infrastructure team is providing. You or like infrastructure team members, they can for example, want to know where some secrets are, because secrets in Kubernetes, it's a special beast. So when you, for example, update your deployment, Kubernetes will see that the deployment is updated and will restart the containers and will do the rolling deploys and will do it fancy. But for secrets, if you just update secret, it won't update it. So for example, if you need to do a rotation of some certificate in your organization, how do you know where it is used? So in case of using, for example, Kotlin DSL, you can actually write additional scripts that will help you to look up and do some analysis of your existing cluster. So for example, this is an example of how to do basically find usages of a secret in your cluster. This script is basically goes through every deployment, and for deployment it checks volumes, and if a volume was created from a secret that we're looking for, it will report it. So if you're on infrastructure team, it will be super easy for you to understand which teams should be notified about this issue. And there are like many, many more examples of that. For example, internally at Cirrus, because we're targeting Kubernetes, we create Kubernetes jobs for each CI task. There are many modifications that we can use. For example, if your particular task is not very important, it's not a deployment, it's not a master, it's some PR task, then it can have smaller priority, or it can use preemptible VMs on Google Cloud. And preemptible VMs, they are like 80% cheaper, so you get the benefit. And you can have, first of all, a bunch of helper functions, like normally you have in your day-to-day programming life. You can have some things to share, as well as use normal for scripts and if statements, not like in the YAML file that we saw before. And I think this is pretty much it. We have 5 minutes left. I don't know if we do Q&As or we don't. After the talk, yeah, I'll be here. And if you are watching live, I'm also available on Twitter, so just tweet at me. And yeah, thank you.
Okay, can everyone hear me? Cool. Well, thanks for sticking around in the conference long enough to attend the last talk. Thanks for attending. My name is John Rodriguez. I work at Square on the Cash App team. We do peer-to-peer financial services and payments. And I'm going to be talking about effective Swift Kotlin interoperability today. Some context is, if you saw Alex Strong and Ben Asher's talk the other day on how multi-platform is being used in their respective apps, you'll know that we already have some multi-platform usage in Cash App, and we're looking for like additional ways to continue moving that. And so as more of the team starts exploring this, like in this talk, I want to share my experiences in it so far, provide some early insights from my perspective, things to be mindful of, and maybe even provide some advice. But this is still a work in progress for me as well, so feel free to, draw your own conclusions on it. Okay, so over the past year, multi-platform fever has swept the world with the promise of code sharing between the iOS and Android code bases. But how does it really work? TLDR turns out with a lot of help from Objective-C. For instance, Objective-C can be used in Kotlin if it's properly imported to this build using C interop. This means invoking the native compiler to generate bindings, which will serve as a proxy to the compiled klib binary. Swift can also be used in Kotlin if the corresponding Swift API is first exported to the Objective-C API using the @objc compiler attribute. Now, you may be wondering, how could I be talking about effective Swift Kotlin interop if no such thing exists? And the truth is, when I submitted this talk back in May, I took a bold bet that JetBrains would probably offer some pure Swift module support, since a couple of months prior, Swift 5 was finally released declaring ABI stability. But alas, here we are with no pure Swift support at this time. But nevertheless, we still find great utility from Kotlin native providing bidirectional interop with the Objective-C and Swift programming languages. However, for the rest of this talk, we're going to be talking about consuming Kotlin libraries in Objective-C Swift code. In this fashion, the Kotlin native compiler will assemble a framework, which is a library artifact in iOS speak. So first, I'm going to go through the setup very quickly, because you probably saw this in other talks. I haven't really gauged how the other talks went through this, but I'm assuming that maybe you, I don't know who's Android developers, who are iOS developers, or who are back-end engineers here. So, I mean, the first thing what you'll do is obviously install Android Studio and configure Android-specific things like the build tools, the platform tools, and the runtime. And then you'll create your new project. It'll just create a little Hello World Android application. And then where you start to actually move into like multi-platform things is when you first create this shared code module. And then in its build Gradle script, start setting up things that are part of the multi-platform setup. And so applying the plugin and then setting up your targets for their respective platforms. In this case, we're really focused on the iOS target. And the framework that we're using in this sample is abbreviated for the name of the talk, so effective Swift Kotlin interop, so that's why it's SKO framework. And then we'll configure the source sets. As you've seen so far, we have like the common source set and the Android source set, and we'll also have an equivalent iOS source set, and they'll just point to their respective Kotlin standard lib implementations. The interesting part is here, because now, as you may know, like iOS and Gradle don't necessarily, like that's not something that interacts normally. Gradle's more of a like Android or backend domain. And so to get this interoperability in your build lifecycle, your development lifecycle, you have to create this task, which is going to just copy the build output from Xcode, or rather execute as part of the Xcode build pipeline, the task that will just copy that from the Gradle build into a place where Xcode can then consume it and link it. At this point, you'll probably need to build your app in order to generate that dynamic framework on your file system, because then you're going to pick it up when you do the next Xcode setting. In this quick sample, you'll see that we pretty much just have a couple of actual implementations for one expect. And so this is pulled from the JetBrains tutorial that just shows how you do the multi-platform stuff. In this case, we're just showing like the device, the platform name, so a very platform-specific printout. And then moving on to Xcode, if you go through the tutorial, you know you have to first link the framework in order to compile it into your binary and dynamically link it. And so here we add the framework to the embedded binaries block, and this will help Xcode be able to resolve imports from Objective-C and Swift. Next, we'll have to add the framework path to the framework search paths block, and then the binary executable will use that path to look for the required frameworks. Finally, we add that Gradle script to hook everything together, and at this point, it should be able to build, pack, and link the native framework. And again, there's a tutorial that goes into this in more detail. You can always take a look at it at that link afterward. But the point is to get to an initial setup. Well, after completing the lab, you'll see this screen upon launching on both clients. And the purpose of this is to create a sandbox from which the rest of this talk will start experimenting and looking at Objective-C headers and seeing what different Kotlin variants will actually generate. So what's actually happening is you're building two artifacts, right? One for your iOS client and one for your Android client. The Android client one is an APK. It's pretty much a zip of all the things that an Android device would need in order to bootstrap the app. And on iOS, there's an IPA file that acts as its equivalent. And so through their respective build tool chains, they will consume via either Gradle or the Xcode build process an AAR. Oh, I have that swapped actually. Just testing you. An IPA file should be consuming a framework artifact, and an APK should be consuming an AAR artifact, which would likely have some common jar dependency, and that's where like the shared Kotlin code base will come in. And this is all comprised of that shared code module that I showed you earlier. The way that the expected actual thing is how the Kotlin native framework is linking, but the dependency management from the actual consuming app to the artifacts are going to be done by, again, Xcode build or Gradle. And turtles all the way down. If you had third-party dependencies, multi-platform libraries, they would in turn have their own hierarchical structure. Okay, so that's like the quick and easy setup part of the talk. Now that we've set that up, let's actually start crossing the interop bridge. And so now if we start playing around and just start throwing some very simple like Kotlin primitives in the shared code module, what's interesting is to see what actually gets generated on the Objective-C side. I tried this out first because we know that with the object keyword that you should basically have an implied singleton object, and I wanted to see first of all if this is something that's still respected in Objective-C. And so to do so, I then create. You'll notice that you still have to add the parentheses, unlike in Kotlin, where you don't for instantiating the object. You will have to in Objective-C. But then I print out the memory addresses of each of those instances, and you would expect that the object instance would have a shared memory address, and the class instances would be different addresses. And in fact, those are honored. And so I'm curious then to know how Objective-C handles it under the hood. And so if we look at the actual output headers, we see a bunch of this. And first step is maybe, if you're not familiar with Objective-C, is just understanding what's actually going on here. And so everything starts off by inheriting from this Kotlin-based class. In Java, you have object as your root class, your root type. And for this generated Kotlin native world, Kotlin-based serves as your root type. And what's important to note here is that the three methods that it defines, it deliberately takes the constructor of NSObject and hides it. It makes it unavailable. That compiler directive is there for a reason. And then what will happen is that inherited subclasses of Kotlin base will selectively turn on that constructor when needed. And in fact, that's how the object paradigm from Kotlin translates over, as we'll see in a second. Another interesting compiler attribute here is the Object-C requires super. it's essentially like the @call super annotation in Java world, where you're basically in implementing this method, you should be calling your parent class's initialize method. For those of you not familiar with Objective-C, if you're prefixed with a minus, you're an instance method, and if you're prefixed with a plus, you're a static method. So that's important for the next thing that we're going to go over. And so now we go to the representation of that object type and that class type that I defined in the Kotlin world. And we see the same subclassing restricted attributes. We could ignore those for now. But you see that we're also supplied with another attribute called Swift name. And so in Objective-C headers, there's this global namespace that just gets concatenated into the name of the corresponding class, and it can get really long really quick. And so instead of instantiating your SKO off object, you can just call object from Swift code, and the bridge will handle that nicely so that the syntax is a little sweeter. Another thing to note is that @interface here does not imply the same thing as interfaces in Java. This is like the API of an actual class for which there'll be an associated implementation in Objective-C world. Interfaces in Objective-C are represented using protocols. And then here's the part that I wanted to call out again. So here you see that on the object class, there's a static method called object, and it's aliased to its Swift name as init, which is typically the constructor. And so it's not actually a constructor, but it's serving in Swift world as a constructor. And because it's a static method, it's able to share the same instance across multiple invocations. That's how you're able to simulate the object paradigm from Kotlin in Objective-C. And then below it, you'll see a regular old class, and it's an instance method. It's its constructor, and it just aliases to a similar name, init. Okay, so let's move on to another example. Let's say we want to increment a variable, something simple just to see how that generates. And in Swift world, we'll try to consume it in this way. Note that the package name, or rather the framework name, and the class file that you created on the Kotlin side will play into the namespace that you then call the method on the Swift consumer side. And what you'll notice right away is that you'll get this error in the IDE. And it's like, cannot convert value into int32. And so it's like, okay, that kind of makes sense. Digging in a little more, you realize that in Objective-C world, that int got translated into an int32 type. And that part of the lesson there is that Objective-C extends from the C programming language from the Ricci and Kernighan days. And back then, the integer type was architecture specific, and so it's similar to the integer type on Java, where depending if you're a 16-bit JVM or a 32-bit JVM, the bytes representing that integer could vary. So does it in Objective-C. But in Kotlin native world, it's a little more strict on enforcing that. Kotlin.int is always a 16-bit integer, and long is always a 32-bit integer. I'm assuming it's because it has to in its cross-platform nature, have to have really strict guidelines on types and can't just be as fluid as, say, Objective-C is. I guess, I don't really know. Truth be told, most iOS devices, including watch APIs, are 32-bit these days. I'm sorry, actually 64-bit these days. I think I meant to say 32 and 64-bit. But there could be a day where it'll be 128-bit. Devices, and so this problem will continue. It's just something to know about when you're interoping with the int type. And so here you go. You'll see that the type is there. And the way to fix that here, unfortunately, didn't really figure out a better way, is just to cast it to int32, which isn't really satisfying. On the flip side, if you were trying to consume the Swift or Objective-C API from the Kotlin world, there's a nice little utility function called convert that'll cast it to the appropriate variant of int for you. But I was unable to find one that would go from a Swift call site of a Kotlin library. All right, that was supposed to be a joke about how Xcode takes forever to resolve errors. So what if we want to increment other numeric types? And so we provide other integral values here and do the same thing. And what will those look like in the call sites? And so A couple of things is, all right, the same problem that we had with int32, we now have with int64. Because by default, floating point numbers in Swift default to type double, you have to then explicitly define your type for float. But the thing to point out here is, look at those argument names in the overloads for ++. It's random underscores. What is that about? And it's because even though the Swift name attribute does its best to make it feel like native to Swift, there still is a backing Objective-C implementation, and an Objective-C method, I don't know if they're called method signatures, the jargon's probably off there, but part of the method signature includes all the parameter names. It concatenates them. And so because I chose to use the same argument name of value, now there's a tie, and tiebreaker apparently goes to the return value type for sorting. And so the reason why in this screen you arbitrarily see like 2 underscores, then 3, then 1, then 0, then 1, is because on the Objective-C header side, double sorts lexicon graphically before float, before int32, and before int64. I mean, didn't you know that? So the real thing to keep in mind is if you're going to overload your methods for bridging purposes, just use distinct argument names. It's kind of obvious, I guess, if you play with enough Objective-C that it tends to be a little more verbose in its typage, but here's a good reason why. It's probably trying to avoid these type of collisions when generating their respective headers. Okay, so let's move on to a few compromises that you'll have to make in embracing this interop world. Some of them have already been cited. Lack of common library support is asterisk here because if you tried using interop or multi-platform as of a year and a half ago, you realize if you came from a Java world that we've been spoiled. We've had a long list of libraries developed for the JDK, and there are open source libraries as well. gzip encoders, file operations, networking APIs, DP APIs, UTF-8 encoders, things that you never thought like you needed, but you were glad they were around, certainly disappear. But the asterisk is because, as Andre mentioned during the keynote, like JetBrains has been doubling down on this over the last year as well. I mean, obviously, you've probably heard this, the coroutines library. They're also really working with the serialization stuff. And most recently, the datetime library is a huge value add. If you have a requirement for shared code that hasn't been satisfied here, you'll either have to be clever and find a way to decouple it or write it yourself. JetBrains is trying to tackle these areas where they come up. But also the cache team at Square has also chosen to double down on this approach because we really like the appeal of having a shared code base using Kotlin multi-platform, and so we, in a sense, want to help build this community of libraries as well. And so you've probably are familiar with OKHTTP being the canonical web HTTP client on JVM-based devices. But also OKIO as like a better form of Java streams. I probably should have deleted Mashi from there because that's not true. And then Wire also has recently become multi-platform capable, which I'll talk about a little bit towards the end of the talk. We also have, as Alec and Ben mentioned the other day, SQLite, which is multi-platform, and that solves, like, because iOS and Android happen to use SQLite databases, they can easily benefit from a shared API. But that being said, SQLite is not necessarily tied to SQLite implementations. It's a matter of just writing the appropriate driver, and then you can connect to, theoretically, a MySQL or Postgres database. So again, just another tool in the toolbox. Another library I came across that's pretty interesting is this one by Russ Wolf called Multi-Platform Settings. He talked about it, I think, at DroidCon New York this year or the previous year. Or, yeah, one of those. This is a wrapper around the key value pair storage on mobile devices known as shared preferences on Android and NS user defaults on iOS devices. So again, just people in the community providing libraries like this really just benefit everyone and will really help mass adoption of multi-platform. Another compromise is just avoid the UI layer. There were attempts in the past to do things like React Native and Ionic, and we've learned lessons that it's just really hard to build this common UI either. It doesn't look right, or it doesn't provide the feature set that you require. I tend to think that any entertainment of these type of libraries pretty much died with the Airbnb blog because Gabriel Peel is a pretty well-respected person in the community, and he wrote this multi-series blog on basically we tried it, we did our best, let's move on, and I think a lot of people resonated with that. I have never played with React Native myself to have a well-informed opinion, but yep, Gabe does. Luckily, paradigms like Swift UI or Jetpack Compose have rekindled the movement to move logic out of our views anyway. So making customization of UI widgets are fairly easy and straightforward as well. So avoiding UI in your multi-platform setup isn't really a big loss. Now let's talk about some language features that you'll have to compromise on. This is pretty fun. Let's say we want to make an enum class in Kotlin. And we look at the generated code, and aside from the fact that New York became the New York, I'm assuming because new is a keyword and it wanted to avoid that collision. And so this is how it's generated, fine. You'll see that that city enum subclasses from a type called Kotlin enum. And you'll see methods at the bottom that indicate like there's a name and an ordinal. And at reading that, you'll think, oh, okay, it's keeping enum values, and they're comparable. This is exactly the behavior I expect for an enum. This is great. Right, this is the method I was just talking about. But then when you actually try to consume these enums, you'll automatically be told by Xcode that the switch must be exhaustive. And then you're wondering, wait, what are you talking about? It is exhaustive. I just defined it. But it turns out that that Kotlin enum subclass that it inherits from is really not an enum at all. It's just a type hierarchy from a common base class. And so you've lost exhaustiveness in your enum definition across the bridge. Yeah, basically aside from the ordinal and compare to functions, that's all you have. So what can we do? You can just add a default case, thereby just defeating the purpose of an enum altogether. But digging in iOS code, I came across this thing called raw representable. And it basically provides a way to basically, instead of the enum encoding and decoding the raw value backing for you, you can say, I will take care of encoding and decoding this value, because you have the complex logic to do so. And so what if we redefine this enum class now on the Swift side, using this raw representable interface or protocol, and then taking as input the raw value of our previously defined enum. And so we're basically creating a bridge enum. We're taking the framework city that is non-exhaustive, incorporating it as a raw value, and for the cases where it's unable to define it, we throw a fatal error, which it's essentially like a runtime exception in Java, because when you use a raw representable subclass, you need to use what's called a failable initializer, which basically means your constructor can return null. And that's unfortunate because then now you're affecting the call site on instantiating that enum, which defeats the purpose of trying to do this exercise. And so I deliberately wanted to avoid that on compile time and defer to runtime, because I know this would be a runtime case that would never happen. And so if you buy that argument, there is a way to basically recapture the semantics of that exhaustiveness. You just have to write this bridge code. And so that's nice. If you are worried about backwards compatibility, say like you change an enum case later, and now you're crashing not because of a case that would never happen, but it's actually a case that does happen because you've just added a fourth case and you forgot to update the bridge code. You could give yourself an out with like an additional case that you just special case as unknown, and this will help provide some of that compatibility. And so now you go from this previous case, which made us sad, to something that makes us feel, my animations are off, that makes you feel a little more like an enum again, because you've regained exhaustiveness. And now you might be wondering, like, well, that's kind of annoying. Like, do I have to write all that bridge code myself? And so one of the things that I'm positing is this would be an amazing thing if JetBrains, as part of their suite of providing this library or this framework, is if they could maybe write a Swift compiler plugin to code gen this for you. I mean, it wouldn't be outside of the norm of things that they're able to do already in their tool chain, and it seems like a pretty small ask. The thing there is that they haven't yet really provided any Swift native support, and this would be kind of going down that venture. And I don't know what's entailed in that, but I point to the ABI stability as a sign that it's worth exploring, at least in something like primitives as important as enums. Okay, so this is how you would supply the raw value yourself, again, if you were manually bridging it, but again, this should really be CodeGen for us. All right, so let's move on to another language feature that we really like in Kotlin, the sealed class. And so now we have our enum class city well defined and we're happy with it. And now we want to create this, this sealed class hierarchy of different pizza types. So again, we have the same problem. Sealed classes act like enums in a sense on the Kotlin end, but we know, or at least we can guess that when they're generated in Objective-C, they're also going to become just a type hierarchy of classes, and you'd be right to assume so. We also have to add a new case to the city, because we just added that for the dessert pizza in case you missed it. And then in Swift, Swift is a very interesting language is because it doesn't just provide, it has the most flexible enum system I've ever encountered in that it's not just automatically backed by integers. You can tell it like what primitive to actually back it. You can use a raw representable if you want to take care of it yourself. Or you can even use something called enums with associated values where certain cases of your enum could almost have a second dimension of value. And it's something I haven't really seen in other programming languages, and so maybe like F# or something. But taking that paradigm that we worked on earlier, it's a little messier because now in order to keep this exhaustiveness feeling, we will have to do things like typecast because the enums that have associated values can no longer be checked using your regular case statements. But again, because this is CodeGen, who cares? Like if you're writing this, it sucks. If something's generated for you, it doesn't suck as much because you'll never look at it. And then you can, again, achieve this feeling of a sealed class in Swift world using associated values and go on with having this native feel. And so to test this, I wrote some test code, and sure enough, it prints what exactly I think it should, which is great. It really would be great if JetBrains could incorporate this. Of course, enums aren't all what they're cracked up to be. Kotlin native does encounter some problems. I think this was, Kevin Galligan from TouchLab filed this. I encountered this the other day. I think there was a memory leak if you accessed an enum off the main thread, because why wouldn't you? They're enums. And I don't know the state of that bug. But again, just keep in mind that while multi-platform is heavily being adopted, that there's still some things to shake out. I'm going to quickly go over generics because that's always a fun topic. But it's important to know that the state of generics is also one of those things that isn't fully well-defined. And the disclaimer here is I probably pretty much got most of this content from Kevin because he knows this a lot better than I do. And so we make this state holder class that just takes in a generic type, and you can see it here. It just saves the value and then has a getter to pull that state out. And when the Swift world, we want to consume this, and the Xcode will immediately tell us that it can't be coerced to this any type, and you're like, huh? What are you talking about? I didn't declare this as a T question mark. I declared this as a T. Why would you say that? And so if you look at the equivalent Objective-C code, you'll see that there's these nullable markers placed within the code, and the reason for this is just the way how the two languages work. So Kotlin and Swift will define nullability on the types themselves, right? You have like any and any question mark. But in Objective-C, the nullability, I didn't know this, that nullability is defined on the properties and the methods themselves. It's almost like your entry and exit points are where you define the nullability, but the type itself isn't. And Kotlin and Swift take a very different approach. But here we are bridging between two languages that don't speak the same thing. And so the TLDR there is, Kevin wrote a blog post that said, that discovered that if you have an unbounded generic parameter, you will always hit this case. And what does that mean? It means that you will have to, did I just show the same thing again? Oh, to fix it, you'll have to update the generic parameter to have an upper bound of any. And it seems silly, right? Because you didn't really change any semantics there. You said you went from being a T raw type to like a T that is bounded by any, which is going to be all the types anyway. So, but it's a nice little hack. It's nice that just doing that will solve the problem. Because now your error goes away, and if you look back in your Objective-C header, the nullables went away as well. In general, Kotlin has the most flexibility when it comes to generics variants. It supports both declaration site variants and use site variants via type projections. Objective-C, on the other hand, only supports declaration site variants, and I honestly forgot what Swift supports. But the TLDR there is, read this blog. Kevin wrote a lot about it. It's not great. There are a lot of workarounds to it, and if you really want to hear the pains he's had to go through, I'm sure he'll be happy to tell you. And mainly because he implemented the interop for generics on the Kotlin native repo. So again, chat with him. Value types. This is an interesting thing. So value types in Swift are fun, or types in Swift in general fall into these two categories. We'll talk about the value types first. It's essentially, if you're familiar with like C, the idea of structs or unions, those are all value types. Otherwise, you can just point to your primitive types in Java, like your ints, your chars, where they're all called by value. You copy the actual memory to the argument when you're calling the function. But in Swift, a lot more things are value types than you may be used to as a JVM programmer. Structs and enums, sure, but in primitives, sure. But even base collections like arrays and sets and dictionaries, which is the analog to the hash map on the JVM, those are also value types, and so are strings. And so there are huge benefits for this because, for example, let's say we have this test class of an address, and I have almost the same address as my neighbor except for our apartment number, and I just change it. Like a Java developer would look at this and I'm like, you just modified the state of both things, but aha, no, it's a struct, so you didn't. And printing it out verifies that. As opposed to if you were using a class type, a reference type, where what you're passing to the function is a reference, not the actual the contiguous memory location representing the entire person. It's just a pointer to a person. Now you are sharing a single copy, and so you do run the risk of what am I trying to say? You run the risk of modifying data unintentionally, which is a huge source of bugs. And so in this case, I accidentally changed the first name. But value types are really popular in Swift, and you get this unique copied instance. It provides immutability, which is particularly handy when you're dealing in multi-threaded environments. In Kotlin, we do it differently. We do like immutability, right? We don't like bugs, but we instead of doing it from a value type perspective, we leverage the power of data classes. And the reason there is because historically to that, we had Java builders, right? Where we could basically piecemeal construct an object and then lock it in with immutable fields. But that was very verbose because Java. Data class had this nice compromise where you could, as long as you made all your properties vals, you could then keep them all immutable, and when you want, you get this nice little utility called copy that allows you to just mutate the subset of the properties that you want on assignment, as opposed to the builder pattern, which like separated your immutability state from your object creation state in this verbose way. One con, not really, but it surprised me anyway until I really thought about it more, is that if you want to mutate a struct, both the object, the handle, the marker to the struct, and the member must be mutable. Again, thinking from Java world, where I can have a constant reference to my object, but a like mutable field, that should be enough. But because the struct is literally the contiguous block of memory of all the fields together, it's not like you're going to offset into a memory location as like in C pointer arithmetic style. And so when I thought of it that way, it made sense to me why, if you want to mutate it, you have to have everything be var. They're pure data, and they're not objects, and therefore having features like properties or encapsulation through access modifiers are just not a thing. But what if we had something where in Kotlin, where we could have, instead of a reference type point, we could have something like a value class in Kotlin that would achieve the semantics that I outlined earlier. And so if you looked at an array of these points, this is what it would look like in a sense in memory. Each object in the JVM contains a header file that describes class metadata and takes, I think, 8 bits on 32-bit systems and 16 bits on 64-bit systems. It basically scales with the architecture. But then we'll have references. Every element in that array will have a reference to its respective element, which also will have a header because it's also a class. But if these were represented as value classes, then maybe it could be something like this, where you could use the pointer arithmetic model, and all of a sudden now you don't have to worry about mutating your array accidentally because it's all copy on write. There is no value type system based. So what the point that I should be saying is that yes, this is nice, and yes, we want this, but Kotlin can't provide this for us per se, because Kotlin more or less has a great tool chain, but it's a tactic sugar based on JVM bytecode, and so like the JVM has to have this built into it innately, and there isn't anything at the moment aside from the built-in primitives. However, there has been an ongoing effort, I want to say for like a decade, to try to provide this support. And it's not an easy problem, and people are working on it as part of a project called Valhalla. And there was a recent L World release in July that allowed people to start experimenting with a version of the JDK that does provide this value type semantic. But it's early access, so who knows when it'll be stable. So I wouldn't hold my breath, but it's promising, because if this does land in the JVM bytecode, then Kotlin could conceivably pick this up, and then you could get better interop from Kotlin and Swift World. And so there are trickle-down effects by having this innately built into the JVM. Let's talk a little bit about build performance. So we're in this example that I pointed to earlier, we're building all the source sets. And we're doing it using a Gradle command. And so we can look at the Gradle task, and in a talk I gave in the past, I showed some like quick snippet on how you can print a graph of your Gradle tasks. And so what's really interesting is just to see what tasks are dedicated to iOS builds. And it turns out there are not many. You have to basically compile the iOS code and then link it to the framework and then copy it over for Xcode. And that's pretty much it. Cool. So that's cool, 3 extra tasks. What's their build impact? And so if you run this profile command, typical Gradle profile command, you'll see that 60% or so of the time in my trivial sample project, your mileage may vary, was spent on linking the debug framework. And I'm not really too good in the weeds of iOS like frameworks to know what linking involves, other than like from a C static library linking level, but that just seems like a long time in general. 18 seconds to compile a few methods and link it to a framework, and yeah, that just seems like a long time. So maybe I have something misconfigured, but that's definitely an alarming thing for a Hello World project. Another thing is just something that's broken with Kotlin in general with Gradle. There was a bug that I filed a couple of weeks back where if you switch branches pretty much and you use build caching in Gradle, you will always be broken. You will lose incremental compilation because of something innate to the Kotlin plugin. And you may wonder, how am I so sure that it's the Kotlin plugin? Is because I filed this issue with both Gradle and Kotlin, and Gradle closed it within like a few hours saying, nope, it's Kotlin's fault. And in particular, it's because there's one task, the abstract task for all Kotlin compilation, whether it's capped, whether it's native, whether it's just JVM compilation, all the input for that task points to a file path, an absolute file path. And when it's trying to cache your build results, it shouldn't be absolute, because if you're using, say, a remote build cache, the file path of your computer's build is not going to be the same as your colleague's build. And once you start using absolute file paths, all like semantics of Gradle build caching goes out the window. And so it's a bug. It has been triaged. And that is the bit.ly link if you're curious. And if you want to even dig in deeper, that's the line of code that's the problem. I haven't had time to really try to roll up my sleeves and look at it, but I did a grep for the annotation that the Gradle person suggested was the problem, and there's only one instance. So this literally is the line that's the problem. It's not just a matter of deleting the annotation. You actually have to fix the problem, which is why it's not like that trivial, but if it's solvable, you'll get a lot of kudos from the Kotlin community. Let's talk about runtime performance. So this is interesting because as you start to use this, you're going to start to notice build times. And so as your build times degrade or otherwise, you want to like dig in. And so I wanted to start seeing, like, I wrote a merge sort. I wrote it 3 times. I wrote it in with Kotlin multi-platform. I wrote it in Swift, which was interesting because apparently if you sub-array an array, you don't get an array, you get an array slice, and they don't have a common subtype, so now your recursive function breaks and all these fun things. And when you sublist a list in Kotlin, they both use the common list interface type, and it's just the implementation that's different. Sublisting a list will actually not copy the list over. It'll just smartly point to the 2 indices for this, denoting the range of the original backed list, and which is what array slices does in Swift, but it does it as value types, and so there is no type hierarchy with that. And so, yeah, recursive functions just become a little more painful, or maybe I just have to learn how to do it better in Swift. Because I didn't know that's how Swift works, I wind up actually doing extra copies in my Swift version of this. And that's a key point because I want to call out the fact that my Swift implementation is a little less optimal. But by running this 3 different times, and we plot this, we see that even with that suboptimally written Swift code, the Kotlin implementation, the multi-platform implementation, takes on average twice as long to run as the native Swift implementation. Again, this is merge sort. You're not usually running merge sort in your apps day to day, but just think of things that are heavily computing. Now you have a hot code path using multi-platform functions. This is something to think about. The vertical axis is in milliseconds, and for mobile applications, which is what I tend to, write more of lately. This, depending, I'm merge sorting 5,000 elements. If you're like in the 500 to 1,000 element, you're probably like taking 4 milliseconds, which isn't going to drop a frame on a mobile platform, but it's something to think about. Another thing to notice is like the bump that happens at various points, and that's probably because in Kotlin native, you're integrating with the Objective-C Swift world in terms of garbage collection. It uses reference counting, and the unused Kotlin objects are automatically removed, but I don't know how quickly they are removed. I don't know if it's like on demand once the references are automatically deleted, or if it's like done at some time in the future. I honestly don't know. When you then compare to the rest of it, it's not surprising that the Android running of the multi-platform code is more or less what native Kotlin canonical Kotlin on Android would run as. It's much faster, and you can see that if you graph it, they're pretty much equal. So that's encouraging. There is no worse performance for Android to consume the multi-platform library than as if it weren't a multi-platform library, is the TLDR there. Still, despite saying that the Kotlin native runtime is slower on iOS, Andre did mention during the keynote that they are doubling down on making this more performant for their upcoming, 1.3 release, or if this has been released. TLDR, they're working on it. For another case study of performance, again, referring to Ben and Alex's talk yesterday, I ran it on SQLite. So I mentioned that SQLite is a wrapper to consume, to make, basically I don't want to call it an ORM because it's not, but it allows you to interface with a database pretty simply by just using raw SQL, and it'll generate all the mapping functions for you. And so it's multi-platform, and so we have a portion in our app which runs, that searches across our database for all peer-to-peer transactions or Bitcoin trades and using this functionality. And so what's interesting is, this is how you set up in the framework, I searched in my activity for some random guy on the internet and looked at it on both clients and saw what would be the performance if I'm typing his name character by character. And here are the results for in terms of milliseconds. You see that the Kotlin Android search gets a little weird for some reason. Maybe it's the way that we're parsing text differently from iOS. That might be something to look into. But the thing to point out is, and Ben and Alec mentioned this yesterday as well, is that on Cash App, we're currently using this weird JavaScript bridge that we're desperately trying to get rid of. But it turns out that the Kotlin is slightly better, but not too much better than the JavaScript bridge currently is. But it's also not worse. So it's beneficial for us to explore using more multi-platform in our app, because again, we're not doing merge sort here. We're just typing a few characters and conducting a database query. So that's interesting. Another thing, Wire 3 talk that Igor and Benoit from our team gave in New York about protobufs and providing gRPC functionality in Kotlin. The reason why I mentioned this, and that's the link to the talk if you want to watch it, is we're really happy in the past year of converting and modularizing our Android protos from Java to Kotlin. And our colleagues on iOS world are still working with Proto-C and the build tool chains that go along with that. And they're desperately trying to enjoy this lifestyle that we have on Android using this Wire tool. And so over the next year, we're looking to see how we can help work with them to get them on this Wire platform. And so there are multiple approaches that we can take. We can either take Kotlin native approach and have them consume the Objective-C header style, or we can maybe code gen Swift wrappers to interact with this Objective-C header seamlessly. Because again, having the benefits of enums and value objects from a Swift the call sites it would be nice, especially because protos are a very core part of using interaction in your app. My point here is that basically Wire, the way that it works is you have this proto message, and then there's this adapter by which you encode and decode to serialize or deserialize your proto message as a bunch of bytes that you just sent over the wire. And so there is a runtime associated with that is already multi-platform. And so if you have a runtime underneath that is multi-platform, if you just apply a layer over it that can help be consumed by iOS apps, then you basically have most of the work done already, quote unquote. Okay, so let's recap. We covered a lot of disparate topics. So first of all, for effective Kotlin-Swift interop, just beware of int itself because of its platform, its architecture dependency there. Prefer to use int32 or 64. If you aren't sure, just stick to long. Beware of method overloads with similar parameter names, or just be very mindful of your naming in general, because what you consume on Swift is still, what you're consuming on Swift will be nice and easy to consume. The Objective-C header may be a little more gnarly, as you saw with the underscore example. Let's continue to grow the core suite of libraries, because the community just benefits overall and we can move faster. Enums matter. It's a currently sore spot in our today's interop story. However, I provided some recipes that maybe we can dig into. For example, if JetBrains could provide some code gen so that we get that nice Swift experience when consuming the enum. On the other hand, from the generic side of things, favoring more Swift isn't necessarily a great thing, because generics seem to work better with Objective-C. So maybe don't code gen generics, but code gen enums and have a fair compromise. No matter what progress is made, you still won't have value types until Project Valhalla falls on the JVM, and so there's that to think about. There's multiple concerns. Build performance could be better, but we're looking forward to some of the native compiler stuff. I wasn't discouraged by anything but merge sorts. So unless you're doing really heavy ML or computation, I maybe wouldn't work with a multi-platform library in that respect, but most other use cases are fine. The build cache issue is affecting all of us, even if we're not using multi-platform today, so we should just fix that. Runtime performance wasn't too bad, but as I mentioned, heavy computation does pay a higher price, and the future continues to look promising, and we're hoping to have Wire support on iOS for the coming year. And that is it. I'll be sticking around for questions afterwards if you'd like to chat. Otherwise, thanks for attending the talk. And remember to vote.